Hey guys, welcome to the course. My name is Paul and I'm going to be your instructor here. I've been programming since 2012 and have over 8 years of experience automating systems with code. I got started in the financial industry around March of 2015 and have been using TradingView since then. I programmed thousands of scripts for myself and others. Currently I work as a freelancer online, helping people convert their trading logic to and from pinescript. This is going to be my first programming course, but I'm not new to teaching. I've taught programming lessons online and in person for friends and paid consultations. I've also spent countless hours live trading in front of a group of over 300 people. I'm very excited to welcome you on board, and I hope you enjoy the content I've created for you. If you have any questions or feedback from me, please don't hesitate to reach out and shoot me a message. See you in the course. Okay. In this section, I'm going to do a quick overview of pinescript and show you guys some quick things so you can get started. So here I am in TradingView. I'm already logged in. I've got my chart open. Down here in the bottom left, there's this tab here that says Pine Editor. Now open that up and you'll have access to the Pine Editor where we'll be writing the majority of our scripts. So what is a script? Well, a script basically consists of functions and variables. Now functions contain instructions that do calculations, and variables, they store results from those calculations inside of them. Every script requires a study or a strategy function call and some kind of output. In this case is a plot. And we can actually add this to the chart by clicking the button here, add the chart. It will load, and now we're plotting the close. It's plotting here. It's done. If we want to save this, we can go ahead and click on save, give it a name, pinescript1, and now the title that we just gave it will pop up here. We can change the name if we don't like that name, pinescript3, save it. We can make changes in our script, type whatever you want. This little red star indicates it's an unsaved script, so we'll save it. And the Pine Editor has a nice version control in it. If you've ever worked with Git, it's not as good as Git. It's very basic. So select version here. And here we are. I can go back to the changes before I made that, which is this. If I want to open up one of my saved scripts, I can come in here, open a script. And these are all my scripts. I can open any one of these and it'll be there from the last time I worked on it. And I can access every single version I've made of it. If I want to open up a new script, click on the new button. It's a drop down. I can get a blank indicator or a blank strategy. And then down here, these are all built-in scripts that pinescript has made available to us. So let's do an RSI, relative strength index. And I'll get rid of my old script. And this is the code for the RSI. Now, if you're not familiar with the RSI, you can come up here in the built-in functions and strategies and type in RSI. And this is the RSI from the public domain on TradingView. This is the one that you would use. Now you have inputs here, your settings, and styles. And actually, for this indicator, we have these two curly brackets here. That's for the source code. So we can pull up the source code for this RSI. And this is the same exact thing we just saw, but now we have a little lock icon here. And look how it's 8 versions deep. So in order to use this and edit this, we can go make a copy. And we have a copy of it, save it. It already exists in my script. I'll just overwrite it. And now I have this code for this RSI in here. But look, I go back to new. RSI here. Notice how the code didn't change at all, because these are identical. Add to the chart. And look at that. So that's a code for the exact same indicator. And you can do that with a lot of them. You can check them out all in here. If you like a script that you're working on and you have a bunch of scripts inside of your folder, you can just start and it'll favorite it. If you want to share a script with the public, you can go to publish script right here. It needs to be on your chart before you do that though. If you need help, there's extra documentation over here. You can hover over the keywords and a built-in Reference manual will pop up. If you hold Command on a Mac or Control on a PC and click the highlighted words, you'll have the reference manual pop up. If you want the reference manual in a separate window, you can come over here in the Help and pop up the reference manual over here. And it will load. And now this is the reference manual. You have all the information you need on the different operators and variables and functions built in the pinescript that you can use. So go ahead and open up the Pine editor, mess around with it, get familiar with it, add some stuff, open up some stuff, save some stuff, break some stuff, and get familiar with it because we'll be working in this. Moving on to some basic syntax. In this section, we're going to be exploring the fundamental features of pinescript. So by the end of this, you'll understand how a script is structured, the different versions there are. You'll know the difference between a study and a strategy, lines and indentation, and comments. So how a script is structured. Here I have the RSI script. This is the RSI. If you've never used it before, it's just an indicator, and this is the code for it. So the first line of this script is going to be like all the scripts you're going to look at. It's going to be this /@version=4. This is actually a directive for the compiler on the back end in TradingView. You don't actually have to have it, but you should. It's just basically telling what version to use in the back end. The most recent version is number 4, so we're going to be using that. But as you go through other people's scripts on TradingView, you might find version=3, you might find version=2, or the first version of pinescript, number 1. If you don't include this, TradingView will automatically default to version 1. You don't want that, so make sure this is always at the top, version=4. The next line is going to be an annotation function call, and it's going to be study or strategy. So you'll see this in all the scripts. You have to have it, but it can't be both. It has to be either study or strategy. And then after that, you're going to have a series of statements which actually implement the algorithm you're trying to run. So in this case, it's the RSI. And this right here is basically everything you need to calculate the algorithm for the RSI. You can put functions in here, other calls, there's all kinds of stuff goes in right here. It doesn't really matter, the order doesn't matter, but it usually always comes right after the study or the strategy. If you're using a study, you need to have at least one function call that outputs either a plot or a bar color, something that outputs to the screen. So if you were to run study and then just this, it would throw an error. So you need to have something in here, and in most cases it's plot. For strategy, it would actually be some kind of strategy call that would output to the screen, like strategy entry. And you probably don't know what that is right now. If you do, that's good. If you don't worry. We'll go over that in the future lessons. This is just an overview of how the script is structured. So you just need to understand that you need this directive at the top. Well, you actually don't need it, but it's highly recommended to put it in there because otherwise it'll default to 1. And then the next line you'll usually see is this study or strategy. Then all these statements, and then the plot or a strategy function call. And strategies actually can have the plot functions as well, but they do need the strategy calls. Moving on to versions. There's currently 4 versions of the pinescript language, where the first one is the oldest one, version 4 is the newest one with all the new features. If you forget to include the version directive at the top of your script, the compiler will default to version 1. pinescript language versions are incompatible with each other. So if you're using version 3 and you want to use the features from version 4, it's not going to work. Just make sure that if you are modifying an existing script and it is version 3 or version 2, or if there's no version at the top, then make sure that you're using the same version. Most version 3 scripts can be modified with just a click of a button that TradingView has nicely included in their Pine editor. So this very simple script, I put version 3 at the top, and then automatically this pops up, convert to version 4. So you can just click that and it converts to version 4 for you. Version 2 and 1 don't have that, so just be aware. Study versus strategy. Here's the features of a study. You can plot information on charts. Studies contain calculations inside. You can't use studies for backtesting, and studies can't contain strategy calls. These are special functions for strategies. in studies, you can use the alert condition call, which will help you set up alerts, and you can get messages to your phone or your email or a webhook. Basically, it alerts you if there's a condition. For strategies, you can do the same thing. You can plot information on charts, just like studies. They also contain calculations, just like studies. And these are actually used to run backtests. So in TradingView, there's another tab for backtesting. You need to have the strategy function call to see the metrics on that. They can contain the strategy calls to generate buy and sell orders. They actually have to. So if you don't have the strategy calls, the strategy won't work. And the funny thing about strategies is you can actually include the alert condition function, but you cannot use it in the strategy. It'll work, you won't get an error, but you can't use it. So that's something to be aware of. When I first started programming in pinescript, I ran into this exact error. So I posted this March 12th, 2016, more than 4 years ago. And then I was looking for help for this alert condition. Basically, it was a simple MA cross. And see here, I was using version 2 at the time. I think that was the most recent version. And I used a strategy call. I set up all my calculations in here. And then down here, I had the strategy orders for my backtesting. But I actually had this alert condition here because I wanted to know when there was a cross of the MAs. I wanted to be alerted. It compiled. I was able to add it to my script. There was no errors at all, but I couldn't add the alert and use it. And I was really confused, so I posted it on here. I got help, and this person answered me 2 years later. Alert condition doesn't work in strategy, only in study. And then other people answered that as well. So I'm sure this helped out other people, but at the time when I was learning this, there wasn't a lot of information. But it's still exactly the same. I don't know why TradingView didn't update it. That's just something you guys need to be aware of so you don't waste time like I did.
Alrighty, lines and indentation. So what is a line? A line is basically an instruction for pinescript. We often refer to these lines as code or statements interchangeably. So this is line 1, this is line 2, line 3, and so on. Empty lines, like on line 4, have no effect on the compiler. You can have as many empty lines as you want. As far as I know, there is no known limit for the amount of lines you can have in a script. So if we come down here, there's 73 lines in this script. I can just keep on adding the lines, and I've never met the bottom. Save that, it's all good. There's also no known limit for the length of one line. So on line 3, if I want to write all my code on one line, and I can do this by just copying this here and pasting it as many times as I feel like, it will just scroll over. I can save it, and TradingView won't give me a problem. In most cases though, you'll want to turn this into a multi-line statement so it's easier to read. This is where indentation comes in. We can expand our single line instructions onto multiple lines by using the proper spacing from the edge of the editor. And the edge is over here on the left. So I'm going to go back to the previous version before I save that. Reset this. So in order for me to create a multi-line statement, we need to prepend each subsequent line with any number of spaces that is not a multiple of 4. So for line 3, if I want to change this and put this onto multiple lines, we'll need to bring the next instruction onto a new line and prepend it with at least 1 space, not 0 spaces, not a multiple of 4 spaces, not 8 spaces, not 12 spaces, and so on, or we'll get an error. So let me show you guys how to do that. So here we are on line 3. I can just hit enter or return, drop that line down, that instruction, and then add 1 space. Go ahead and save, and it's fine. I'll go ahead and add this to the chart as well so we can see it and make sure everything's looking good. So this is very simple, it's just 4. You can see 4 is being plotted on this red line, and I have the plot function down here. So if I want, I can turn that into a multi-line, and I can even make it 2 spaces. I can do the same thing here. Make that 3 spaces, and the spaces in between your operators and your operands don't matter as well. Save that. It's all good. If I want to drop this down onto another line, add another space, that's 4 spaces. That's not going to work because that's a multiple of 4. And you see down here we have an error in the console, line 3, syntax error at input, end of line without line continuation. So if you click this, it will just bring us up to line number 3, and it doesn't actually show us that our error is down here on line number 7. It's a spacing error. It's not very clear, so keep that in mind. If we go ahead and add another space, not a multiple of 4 anymore, it'll work fine. And if you notice, after 5 spaces, the pine editor will draw a dotted vertical line right here, indicating every 4 spaces, so you don't have to count your multiples. And then after 9, you get another multiple of 4 vertical line right there, and you can keep on seeing them. So the pine editor will kind of hint to you if you're on a multiple of 4 when you're making multiple lines. Save that, even that's okay. You cannot have comments on a multi-line statement that contains an instruction. So for example, if I wanted to add the comment here, say +1, and save this, because there's also an instruction, there's a piece of code there, there's +1, I actually get an error, and it's the same exact error as before, but this time it's because we have a comment. However though, if you would like to add some comments, you can do this by adding a line that only contains a comment without any instructions. Like this. Go ahead and save that. And nothing's wrong. Additionally, you can also have blank lines in between your multiple lines, and everything will still work fine. Save that, no problem. Have as many blank lines as you want. Multi-line statements will also work for built-in and custom functions. So here we have this built-in function here, the plot function. This is how we're plotting A. And I can go ahead and just drop this onto another line. Make sure there's more than 0 spaces. So I have 1 space in this case. Go ahead and save it. And it works fine. You can do this here. Here, even here. Make sure there's 1 space. And it doesn't really matter how you space it out. It can be ugly if you want, just not a multiple of 4. That's it. And for custom functions, we haven't covered those yet, but the syntax is essentially the same. The only difference is where we start the indentation. With custom functions, they require an additional indentation of 4 spaces, which actually defines the code as part of that function. We'll cover custom functions in more detail in another video, but when you're making multi-lines inside, it's exactly the same. However, the edge of the editor inside of a custom function actually starts here, 4 spaces in. If that doesn't make sense right now, don't worry, we're going to cover that later. And that's it. Moving on to comments. pinescript supports single line comments only. So if I go back and I show you the multi-lines we were just talking about, if you were to put a comment in this multi-line statement, it won't work. So if I try and save this, it doesn't work. But I can put a comment anywhere else, like up here. I think I can put one after the directive. No, I cannot put one after the directive. So you can't put them after the directive. That's the first one I've done that before. But you can have them pretty much everywhere else on their own lines. You can have them after statements. Basically, anywhere after the 2 little slashes is a comment. And to recap, we went over how a script is structured. We saw at the top of a script, we have the version directive, which tells the compiler what version we are using. And the next thing, we had a study or a strategy annotation call. In between that, we have statements, function calls, calculations, whatever else. You can order them whatever way you want. Inputs, variables. And then after that,
you have to have an output of some kind. If you're on a study, it's got to be a plot or some kind of color, background color function, something that outputs to the chart. If you're on a strategy, it needs to be some kind of strategy call that buys or sells. Doesn't matter, but it needs to be one of them. Then we went over versions. There's 4 different versions. The default version is 1, so if you don't have the directive at the top, the compiler will default to the first version. 4th version is the newest one currently as of June 2020, so you want to make sure you're using that for all the features. And all the versions are incompatible with each other. If you're on version 3, you can easily convert to version 4, but if you are in another version or you want to modify an older version, you're going to have to do some work to get it to work. The differences between a study and a strategy, we went over that. Basically, strategies are made for running backtests. Studies are made for using alerts and indicators on your chart. You can plot and calculate with both of them. They essentially do the same thing. We went over lines and indentation. I showed you guys that lines can be as long as you want, but you'll probably want to span those long statements over multiple lines, and I showed you how to do that. You need 4 plus 1 or 2 or 3 spaces, no more than 7. So if you have 8, you're going to get an error. If you have just 4, you're going to get an error. Comments, anything after these double slashes is a comment. They can't be used in the multi-line statements, and that's it. Hope you guys learned something. Variables in pinescript. In this section, we're going to be talking about variables. We'll be covering topics about identifiers, variable types and assignment, even reassignment of variables, variable forms, and reserved variables. So, identifiers are basically just a naming convention used to identify, get it? Identifiers identify user-defined variables and functions. So in this picture below, these are all identifiers here. On the other side, these are just variables being assigned to these identifiers. And each identifier is different. You can call it whatever you want. It's just a label for a variable, so you can refer to it later on. It can also be a function, but these are variables. And you will actually see me refer to these identifiers as variables as we go on. It's kind of interchangeable. Just think of it as identifiers as labels for variables. Okay, so what are identifiers composed of? How do you make one? Well, basically, it's just upper and lowercase letters. You can have an underscore in them, as you can see in this example. You can have digits 0 through 9. The only thing is you can't have digit at the start of an identifier. So there's no example here, but I will show you guys. You can't have like a 1 and then the identifier name. It'll throw an error. Also, these identifiers are case sensitive. So if you have a capital letter in one and not a capital letter, those would be 2 different identifiers. What types of variables can you assign to identifiers? So integers, floats, strings, these are like sentences, words, characters, anything that you can put in quotes. They can be single quotes or double quotes. Booleans, this is a concept in programming. It's basically only 2 values, true or false. You can also assign colors to these identifiers, and these are in hexadecimal, or there's a named constant that you can use. Line and labels, those are new to version 4, and I'll show you how to assign those to identifiers. Plots and H-lines, which is horizontal lines, you can also assign those to identifiers. And the NA variable, which is, if you've ever worked with JavaScript, that's the null, and if you've worked with Python, that's none. It works kind of the same way. Alright, so before I bore you guys out of your minds, we're actually going to jump into the Pine editor next, and we'll just go over some more examples. Alright, I'm going to go over some examples for you guys. These are all the different types of identifiers. So this one starts with a 1, and you can't have that. If I go and save this, it's going to give me an error down here, syntax error at input 1. And it actually tells me the line 14, which is nice. You can click on here. If you didn't know that, it'll bring you up to the line where your error is at. This one right here, there's some illegal ASCII characters in here. I'm using an exclamation point for the eyes. You can't do that. It's only A through Z, capital letters, digits, it's underscore. See here, mismatched character,
F expecting equal. It's not exactly the perfect error output, but at least it tells me which line. Uncomment that. And then this one, I'm using a hyphen. And as you can expect, same thing. So this one actually tells me at input hyphen. So don't do that. Don't put a number in front of your identifiers. Also, it's case sensitive, so you can have A equals 1 or A equals 1. And those will be two different identifiers, which hold, I need a plot function in here. So back to section 1. You always have to have a plot function in your studies. But here, A equals 1 and A equals 1, those are two different variables. So I could put in something else here, and it works. But if you do this, this actually won't work. It's already defined. Moving on to numbers. So this is going to what types of variables can we assign to our identifiers. And here we have integers. I just labeled this identifier as integer number 1, 2, 3, 4, 5, 6, 7, 8, 9. It can be whatever. Float numbers. This is a float with a decimal point in it. There's also scientific notation, so you can use the E here, which is actually 6.02 or times 10 to the 23rd. Also, you can have a capital E if you want. Also, you can do negative, so some very tiny number, tiny float number. Those all work perfectly fine. Strings. Strings can be a little tricky. You can use single and double quotation marks. They basically do the same exact thing. There's no preference. Yeah, use whatever one works for you. A string enclosed within double quotation marks can contain any number of single quotation marks and vice versa. So what that means down here is this identifier string 3. I've got over here, I have these double quotation marks, and inside there's a single quotation. There's also one here. And then the same thing. These are singles, and then I put some doubles inside, and it works. If you try and write it out like this, where you have single quotation marks and a single inside of it, it closes the string right here. And now that actually won't work. It's a bad string. The same thing with the double quotation marks. However, if you do actually want to have a single quote in your string that is between two single quotes, you can do that. The way you do that is with this backslash, and you pre-pended that single quote with the backslash, and now it works. And the syntax highlighting in this Pine editor is good enough for you to understand that this works. See how it's all green? And up here, if I throw in a quote, now it turns white. You can clearly see something's wrong there. And if you can't, you press save and add it to your chart, and you go to where the error is showing up. So here, same thing with the double quotes, the backslash. So now I have a string with a backslash, double quotes, string, in a string. Stringception. Numbers that are strings are actually just strings. So pinescript won't view this 1 as a 1. It'll see it as a string. For booleans, basically pretty straightforward. False, true. If you don't know how these work, if you look at the plot function, so if we're plotting the close here, if you look at the annotation, you can add in different parameters for this plot function. And one of the parameters is to track price. And if I click it here, I can actually go down, and you can see input bool is the type of variable that you can use for it. So if true, then a horizontal price line will be shown at the level of the last study value. Default, it's false. So what does that mean? This isn't going to do anything. I mean, I could do plot, close, save. Look at this, and it's plotting the close. So now if I do this, I'm going to go track price, which is a parameter built into this plot function, and I put this true. Now this Boolean tells pinescript that we want a horizontal line on the actual price, and you can see it here. But I don't actually need to write true in there because I assigned true to this identifier bool _2, and I can do the same thing. But to show you there's a change, I'll do it as false, and that's saved, and now it's gone. So that's one thing you do with assigning variables is you would use them throughout your script like that. Colors, you can assign the named constant and command click, open up, and here's all the colors that you can put in. You can use the hexadecimal syntax. You can assign both of these variables to these identifiers and use them. And here I have a little example of the plot. I'm taking this color 2, which is actually yellow in hexadecimal, and look, there it is, yellow. This is also another parameter in the plot function. You can assign the color for your plots. And just to show you that it's working, I'll assign color 3. I don't know what color that is. It's red. Okay. I'm not a hexadecimal expert. And color 1 should also be yellow. And look at that. There you go. And you'll notice here, actually, I gave this title of this plot, the title of string 3. And string 3 is this all the way over here. You're probably wondering where that is. If you want to look at the title, you can see it here in the style tab of this indicator. I'm a double quoted string with single quotes inside. Looks like the Pine editor took out those double quotes inside of this string, at least in the GUI they've made. There's also a data window that you can utilize. You can see the same exact variable over here. So it's helpful if you're trying to debug something. You can put a title on your plot and kind of see it over here if you give it a title. If you don't, then it'll probably just say plot, and that's not very helpful. Like this. And now I'm in the data window, plot. Now there's only one here, but if I had, say, 40 plots, then they would all be named plot. And what are you going to do with that? You probably noticed that all of my identifiers have different names. So if you actually, you think that you can reassign that identifier to another variable, you can't do that. At least not with the equal sign. You need to use this special syntax, which is like a little walrus operator. So use that, and there you go. So that's how you would reassign a variable throughout your script. If you run into myvar, whatever your variable is, it's already defined. Just remember that. And something that you might see as you work with more scripts is tuples. And these are useful when you start designing your own functions. I won't get into too much detail right here because we haven't gotten into functions yet. But just to go over it real quick, this is a function that I define. It's real simple. It's only on one line. All it's doing is just getting the high and the low. Before version 4, you could only return one variable from a function, and now you can return more. So basically in this function here, I'm returning the high and the low, and it returns those two variables back into these two identifiers that I made. Other variables specific to pinescript that you won't see in any other languages. Plot and hline, you've already seen the plot, but you can actually assign the plot to an identifier. And the only reason you would want to do this is so you can use the fill function. And the fill function basically just takes in two variables and fills the space in between them. So I'll show you what that looks like. So here I'm plotting the open. I gave it a title, plot open variable, and it's yellow. And then the next plot is for the close, and it's red. Here we go. Let me zoom in a little bit. And in between, here, let me show you. So if I get rid of this fill, it will still plot. And now you see the yellow plotting the open and the red plotting the close. They're kind of very close with each other. But the fill, this is the only reason you would assign them to a variable, is so you can put it in this function and get this color. I put green here, and now a green color will fill in between those two plots. So as you can see, okay. Moving on to H-lines. These are pretty much the same thing as assigning plots to identifiers. And an H-line, all it is a function for putting a horizontal line on the chart. So let me just show you what that looks like real quick. And all that is these little gray dotted lines. Right here. I'll change them to green so you can see them clearer. but that's basically your horizontal lines. And the only reason you would want to assign them to an identifier is so you can use them in this fill function. And I already did that for you here. And now this should change to, well, the default color is blue. So if I wanted to change that H-line's background, and we'll move the opacity, there you go. So that's that. That's all that is. But without assigning them, the H-lines will still work, but we can't assign them to the fill unless you did this. So you don't really need to assign them to an identifier, but you should know that you can do that. And here you go. Same thing. No errors. It works. H-line's background, opacity, boom. Moving on to lines and labels. These are new in version 4. So if you try to use them in version 3 or 2 or 1, you will get an error. But basically, same exact thing. You can assign it to a identifier. Same thing with labels. Now this is actually something you'd want to do so you can manipulate the line later on. And there's a few examples. If you command click on that, I'm on a Mac, PC is control click. They give you some examples of how you might use that. And you can put this into your Pine editor and test that out on your free time. I won't show you guys this. I'll leave that for another section. And the last variable that you can assign to your identifiers is this built-in variable called NA, which is not available. It's just like null in JavaScript or none in Python if you've worked in that language. Assign it to an identifier, save, and look, it doesn't work. So this is because pinescript has a type casting system and it doesn't know what type NA is. So we haven't talked about types yet. We're going to be talking about those in the next section. They are extremely important because you will run into the majority of your errors if you're getting the types wrong. So we're going to go over that next.
Okay, in the last lecture, we went over different types of variables that you can assign to identifiers. And we left off with the NA variable. In the previous versions, up to version 3, you could actually assign it to an identifier, and there would be no issue doing this. I can show you this right here. Or in version 3, I moved this over. If you haven't seen this before, this is just it's like a plot function. It's BG color. It outputs to the chart, and all it does is color the background of each one of these bars. But in this example, all we're going to see is just NA because there's nothing to color here. For this variable, we'd want to put in a color. So just to show you what I mean, I'm adding it to the chart, saving, and then all we see is NA, just nothing. The way it would work is you'd put in a color here, and in version 3, you just actually can write in the color. You can also use hexadecimal as well, but in version 4, among some other changes that they made, you would have to write it like this. Now the syntax highlights, and it's okay, but the syntax in this Pine editor is always highlighting for version 4. So it's kind of confusing. You'll think you have it right here. If I save this, it's going to give me an error, undeclared identifier, color.green. So even though it looks like it's right for this color, it's actually wrong. That's just one of those changes you'll need to be aware of when you're working with different versions. That's why I told you guys to stay with version 4 if you can and try to convert it. See, there's a button right here, convert to version 4. But I'm not going to do that because I need you to see this and understand this. So if you are working in version 3, you could literally just type green and it would know what color that is. So now you can see the whole background is all just colored green. And that's basically what this function does. So it works. But in version 4, they wanted to be more explicit with this. So they actually introduced some type keywords. And these keywords are int, float, bool, and so on. So there's actually a line one and a label. And these basically help you identify the type. And there's a color one as well. You don't normally need to use these. Like we didn't need to use these in the last section because pinescript's compiler in the backend has an automatic casting system, which basically is pretty smart. It can tell what type your identifier is going to be based on what it's equal to. With the NA, it can't really tell. So now you have to be explicit when you're in version 4, and you have to tell it what type it's going to be. So in this case, I want this variable to be a color type. It's still NA. Let me switch to version 4 too, because it won't work. But now the compiler in the backend knows that this is going to be a color type. We can do this, it saves, and it works. We get no errors. Of course, if I didn't have that, pinescript stops me and says defined without type keyword. And the type keyword is this. So we can do that, add that, and there's no background color. So this is the example I want to show you guys. This is the close, greater than the open. And if that happens, then you want the background color to be green. Say if we didn't have these bar colors, then you could do it manually this way. So in this case, whenever the close is not greater than the open, the background color is nothing, it's NA, and then whenever it is higher than the open, it's going to be green. Similar to what we're seeing here. So we do that. I got to change this green variable to actually the version 4. And look at that. So now you have this background color, which is basically doing the same exact thing as the candlestick. It's just changing it to green. And then where it's not, where it should be red or whatever color you want it to be, it's just NA. And now obviously I could make this, I could set this to color red, and then it would be red. But in that case, I don't need to tell it what type it's going to be, because the compiler will automatically know based on the type it was initialized at. But if you want to read more about the changes from version 3 to version 4, this is one of the major ones. There are other changes. I'll leave this in the resource section, but they have it in their blog. If you want to get familiar with it and just kind of understand it, they have all the changes they made here. And actually, explicit variable type declaration, this is exactly what we just went over. And you see this is done to avoid a number of issues that arise when the variable type changes after it's initialized with the NA value. Hopefully that makes sense to you guys.
Here we are on the Pine editor, and we're just going to look at some quick ways to pull up the reference manual so you can view all the built-in variables. Over here in the right corner, this little help drop down, there's a pinescript user manual, pinescript reference pop-up, pinescript reference new window. Both of these ones right here are the same thing. The only difference is this pop-up will pop it up inside of your current tab, and the other one will open up a new window. So if you want to view the reference manual while you're coding and you have a second monitor, that's useful. If you're like me and you're working from your laptop, you can just have this reference manual pop up. You can also use command click, or if you're on a Windows, control click, and it brings that up as well. So that's kind of a hotkey. So here we are. Here's all the built-in variables. There's also built-in functions and operators we haven't gotten to yet. Close. This is one of the built-in variables we've seen quite a few times already. It's basically the current close price. It tells you the type, which is a series float. Series is a form. We haven't gotten to that yet. That's going to be in the next lecture. There's also remarks about the close that are useful. Some of these variables will have examples on how to use them. Like right here, bar index, it kind of gives you an example of how to use that. So I suggest going through this list and just kind of checking out the types of variables that pinescript has made available to you, so you can kind of get a better idea of what you're going to be working with. There's intraday intensity index. I've never used that, but it's there. Input values. And for the hotkey, you could type in something like input, then period, and then alt space, and this little tab pops up, which is very handy. Fills it in for you. Okay. All right, now we're going to talk about variable forms. Now this lecture is going to be kind of hard to wrap your head around, so don't expect to understand it all right away. I promise it will click eventually, but if you do skip this because it's boring or just hard to understand, you're going to be finding yourself banging your head against the wall, because this part of the lecture is really important, and it's something that I didn't come to understand until a couple years down the road. And I spent a lot of time trying different pieces of code, trial and error. There were no tutorials when I was going through it. I wasted a lot of time, basically. So you want to pay attention to this. Just get through it with me. It's tough for me to explain this. It's going to be tough for you to understand, but I promise it will click as long as you get this in your head and you understand that these are there. This is a thing, and you can go and learn more about it as you learn. So every type that we talked about has a form, and there's currently 5 forms that you need to know about. There's a literal, const, input, simple, and series. So you don't see these when you're coding, but you can see them in the reference manual. So here we have const color, and color is the type, const is the form. Here's another reference for the close, and that's a series, but it's also type float. And another example to show you here is bar index. It's also a built-in variable. The type is series integer, where the series is the form. So the literal form literally represents a fixed value. This one is pretty straightforward. Here we have 3.14, that's a literal float. 42, it's a literal integer, and so on. Literal bool, literal string, literal color. And here I put in the little plot function where we have this built-in variable close with the title parameter equals a literal title. Moving on to const form. This form does not change during script execution. It's known or can be calculated at compile time. And it's typically referred to as a constant because this form remains constant throughout the whole execution of the script. You have constant int, constant float, constant string, constant bool, constant color. As an example, here we have this literal int, which is being assigned to a identifier, and on the back end, this identifier is going to be called a constant int. Because if this was the whole script, say that at the bottom here we had a plot function and the version at the top, C1 remains the same throughout this whole script, so it's constant. It does not change. And here you can actually see we're using a constant int plus a literal int, and it equals C2, which is just another identifier. And C2 actually remains constant. We don't see it anywhere else in this script being modified or changed. It remains constant. Same thing here. We have constant int. Again, we can use the same constants. It's not changing. Plus this literal int. It's being assigned to C3. C3 is now a constant int. But down here, here's this little if statement. If the open is greater than the close, this is probably going to happen somewhere in the script as it's executing, and C3 will be reassigned, as we have it here, to this literal int. And because we're reassigning it, it changes into a series form. Now, a series form is the most common form in Pine. You're going to be working with this one the most. You're going to see it the most. This one changes during the script execution, as we just saw. You can store a sequence of historical values that are associated with the bars of the main chart, and those values can be accessed using the bracket operator. You can't overwrite the historical values. You can only write to the most recent bar. Basically, open, high, low, close. We've seen these built-in variables. Those are series forms, and there's many more. You can make your own series forms, as you saw in the constant example, where every time you reassign a variable with the walrus operator, it changes, and therefore it becomes a series. Also, any expression that contains a series variable will be treated as a series itself. We have series int, series float, series string, bool, color, label, line, NA, and there's no such thing as series plots right now, or H lines. And here's an example of a series form and how they kind of work. So here we have the series float and another series float. These are the built-in variables. We're just adding them together. This A identifier will actually end up being a series float itself. Will just be the open and the close added together, the sum of that. Here on line 38, we have series high, which is all the highs in the entire chart. But this one right here is the most current high, plus 2,000. And this plus 2,000 goes across the whole chart. And this is a literal int, but because this is a series and we're adding them both together, the series takes priority here, and this identifier here will be a series form. And here we're showing you how to use the bracket operator, and we're actually referencing yesterday's close. So it's zero-based indexing, and 0 would be the most recent, the current bar that we're on. 1 is yesterday. And C is actually a series form as well. And you can see here, if you hover over the close, it shows you built-in variable and the type series float. So all the open, close, high, low, those are all series floats. The next form is the input form. The input form does not change during script execution. It's unknown at compile time, and basically all you really need to know is that it originates from an input function. We have input floats, input ints, input strings, input bools, and here's some examples. Basically, whenever you use this function, the input, and you assign it to a variable, you get an input form. We haven't really worked with inputs too much, but it's basically when you want to use user-defined variables on the front end. So here's the front end. If you were to go to settings of an indicator, you'll find a bunch of inputs, and these are the inputs we just made in the example. Input integer, and that should be pretty straightforward. Here's the input bool, check, and that's how you change your settings with inputs. The last form is the simple form, and this one does not change during script execution. It's unknown at compile time. These are values that come from the main chart symbol. So these come as simple floats, simple ints, simple strings, simple bools, simple color. And simple is usually omitted. So when you're looking at the reference documents, you'll see actually the type is just float. It doesn't say simple float or simple int or simple string. You won't see that in most cases. You'll just see the name of the type, which is just float in this case. We're accessing the docs for siminfo.mintick for that built-in variable. So basically, in most cases, you won't need to worry about what form your variable is. Just remember that forms are just different varieties of the types. Kind of like water has 3 different forms: ice, liquid, and gas. Simple, literal, and input and const forms are pretty much all almost identical. Mostly just pay attention to if it's a series or not, and let the automatic casting system in the back end take care of the rest. If you screw something up, there will be an error, and it will tell you and let you know that your form does not work.
In this section, I'm going to go over some variable operators, and we're going to focus on arithmetic with these variable operators. There are 5 operators that you can use for arithmetic in pinescript. We have addition, subtraction, multiplication, division, and the modulo operator. Now I'm going to go over each one of these and give you guys some examples so you can understand how to use them. So addition and subtraction, these are pretty straightforward. We have this first line here in line 15. All I'm doing is adding 2 constant integers together. 2 plus 2 equals 4. Very simple. And here, subtraction, I'm just using basic subtraction and addition symbols. 2 minus 2, constant integer, 0. Exactly what you'd expect. You can do the same thing with floats. 2.0 plus 2.0. You can even add floats and integers, no problem. The result would be a float. Like here, float int 2. 2 is an integer, and this is a float. 2 plus 2. The result would be a constant float. We can also add series and integers or floats together. The result would actually be a series float. So across every single bar in the close series, you would have that plus 4 across the entire thing. And if you add an NA variable to an integer or a series or a float, it would actually end up being, the result would be NA. And same thing if you subtract it. So if I plotted always NA, if I add this to the chart, let me save it and add it to the chart, the result will always end up as NA. So there's a way to actually look for NA variables when you're doing calculations, and you check, you go, okay, is this an NA variable? If it is, then do this. If it's not, then do that. And yeah, see, it's always NA. At least this first one here. So if we look at the data window here, you'll see plot, which I didn't give it a title in here, but it's the first plot I have, and it's always going to be NA. Even though I have 2 here, I can even go in and add plus close, and you can stack on operations, -4, and if things are starting to get tricky, you can put things in parentheses. Whatever is in the parentheses gets done first, and then on the outside. So close -4, then +2 plus NA. And the result, because there's an NA in there, will always be NA. And you see this plot, what do you know? It's NA. Another cool feature when you're using the addition, the plus symbol, is you can concatenate strings together, which basically just it's like adding two strings together. So here we have string 1. I just put them in identifiers. You don't have to do this. And current, and notice I have a little space here, current range. And then this is the concatenation. I just labeled it concatenation. And all it's going to do is just going to make one string. And I could actually, let me plot that. Okay, close, and then title. And here you go. The title is this concatenation, which is actually current range. Right here. So you can do that. That's the only operator that you can work with strings with. You can't use a minus. So that's a nice little feature of the plus symbol. Also, with the plus and minus operators, they're unary. So you actually don't need two operands on each side for this to work. This is an operand, and what? Let me see. This is an operand, this is an operand. So you can actually have just one, and all this does is it negates this expression. So this is the number 1, and now this identifier is going to end up being -1. With the plus symbol, it actually does nothing. It's just for symmetry. Those are the words of pinescript docs. So the plus symbol really does nothing. It doesn't add one. You'd think it would, but it does nothing. So it's just there for looks. And if I go ahead and plot these, actually it's already plotted. You can see them right here. 1, -1. So unary addition, +1 does nothing. It stays at 1. It's green. And unary add, you can see it here as well as there. 2 different places. And then the -1 actually turns it negative. So let's do a little example use case here. We can actually find the range between the high and the low, which is actually something you might want to do and use when you're actually trading. So here we have, I'm taking the high series, I'm just minusing it from the low series. So it's going to create a new series of the difference between the high and the low, and we're going to call it the range. And I could just plot that as is. Range title equals range, right? I could just add that, and here we have the difference between the high and low all the way through. 11.10, that's the current range. And actually I did it down here too. And I also, for some extra functionality, we had the change. So I'm taking the range from yesterday and subtracting that from the range of today. And this does it all the way across all the ranges. So it'll always be, you know, today's range subtracted from yesterday's range. And that's the change in range. And then there's also a function built into pinescript that basically can do that for you. So, you know, either way works. Whatever way is good for you. You can use this function. This one also allows you to select more than just yesterday. So you can do 2 days ago, 3 days ago, 4. I mean, I can do that here too. So it's kind of the same thing. Exactly the same. I'm just showing you there's many ways to skin a cat. I've never skinned a cat before. I don't even know why that's a saying. But yeah, here we go. Here's the change in range. And I'm actually showing right here in this title, I'm actually doing some string concatenation within the title. You can actually do this within parameters. It's kind of messy, but you can do it. This equal sign. So change plus string 2. And I think string 2 is up here. Range. Change range. Same thing here. And then I actually added another one after this identifier, by. And we can see that. Save that. Look at the data window. Current range, change range by. And see how it's the same exact thing, same number. So it doesn't really matter what you use. It's up to you. Moving on to division and multiplication. So pretty straightforward here. There are a couple intricacies that you should be aware of, but for the most part, division is division. This 2 divided by 2 equals 1. Same with 2 times 2. Use a little star right here, the star operator, the asterisk. That's going to be equal to 4. Same thing with floats. You're going to get a float returned. Same thing if you're multiplying floats, and if you're dividing an integer by a float, you're going to get a float in return. So you can also divide by closes, and this divides by every single close across the entire series. I think you understand that. And then we have this one. This one is closed times 4, so this bar is closed times 4, this bar, and so on. And the result will be a series float. And like the addition and subtraction, if there is an NA variable, then the result will be NA. So it doesn't matter what you're doing. If you have an NA in there, then the result will be NA. And if you want to avoid that, there's a function built into pinescript. I believe it's called just NA. And you can put this around your, so you can put it around here. You know, because maybe you won't actually know if there's going to be an NA variable within your calculations. So you'd put something like this in and see how it says test value if it's NaN. And basically it's going to return a Boolean or a series Boolean, and it's going to say, okay, true, false. And then based on that condition, you can do things like you can actually do your division or multiplication, or whatever it is you want to do. Okay, so things you can't do, you can't divide by 0. This will throw an error if you're doing 1 divided by 0 or anything divided by 0. And you might get slipped up on this right here. So if you're doing integer division, say like 1 divided by 2, you would think that would equal 0.5, but it doesn't automatically cast to a float. So you're actually going to get, I believe, 1 with this. So you need to, if you're going to be doing division with small numbers, just use floats, because it's just going to take, it's not going to actually give you the right values here. So it's actually 0, plot 0. So it should be 0.5, but it can't show 0.5 because it's 2 integers. Here, good fraction, you have the float divided by the int. Same thing, but it actually casts it to a float because there's a float in the expression here. But if you want to do your math really good, just use 2 floats so you avoid any of these issues. Moving on to an example use case using everything we've learned up to now, finding averages. So bar sum, which is just the high plus the low, just add those 2 together, and then we can divide those just like that, and then we get the average between the high and low. So it's kind of like the average price right here. We could also do the same thing here without placing these 2 values in this identifier. We can just place them in the parentheses. So the addition is done in here, and then it's divided by 2. And the result will be a series float of the average between these 2. There's also a built-in variable called HL2. It's the same exact thing, it's just a little shortcut. but at least this way you know how to do it. And if we plotted that, it would just plot the average. I don't think I need to show you guys that, but I'll leave this script in the resources so you can copy and paste it into your Pine editor and you can mess around with it. We can also do the same thing with more values. I don't think there's any limit to this, but this is a common one where you get the average. So common they actually have a shortcut for this one as well. It's called HLC3, which is high, low, close divided by 3, and we can plot that as well. Now if you want, see this value up here, this percent change, we can actually do that within pinescript, and that is the today's close. So this current value, it hasn't actually closed yet, but we can grab it and we can subtract it by yesterday's close, which this one represents 1 bar back, which is right here. So this close minus this close, let me make that a little closer so you can see it. So this current close, it's still moving, minus right here. And we divide that by the current close, multiply it by 100, and we should get the percent change to plot. Nope. Let me comment this out. High-low average is already defined. Okay, I defined it 3 times in the same spot. That's why I use different names for your variables or your identifiers. All right. So double click that, bring it to scale, and negative 0.21. And look at that, it's exactly like this. So there we go, we made our own little percent change indicator. Okay, moving on to modulo. Modulo, I don't really know how to pronounce that. If you know, let me know. But this is the remainder for division. So 5.0 modulo 3, which is actually going to be, here I had the math here, so if you're doing 5 divided by 3, you get 1 and 2/3. That would be the fraction, 2/3, and the modulo would be the numerator of that, which should be 2. So you can do integer modulo, and 2 divided by 2 has a remainder of 0. There's nothing left. And a 2 float divided by 2. I don't know why that's division. Here we go. That should still be 0. And this should still be 0. Float int mod. Not sure why I have 1 here, because there's no remainder when I'm dividing by 2, even if it is an integer here. And we can check that. Let me just do this. And we'll do this, and we'll do title, question mark, because why is that there? And what do we get? Well, it's hard to tell here. That's why we, yeah, see 0 right here. Question mark 0. So let me get rid of percent change and modulus 5. And we can also do series modulos, which does basically the same thing as any other operator with the series. So you're still going to get a series float as you're returned, and it's just going to give you the modulus across the entire series. So it'll be different everywhere. And the same thing with NA values. You'll always get an NA returned. So integer division with the modulo, you're going to get a 1 here, because the remainder is actually going to be 1, and it works here. In this case, I know we talked about using floats for dividing, but in this case, the modulo actually works between 2 integers. See here? So if you're looking for the fractions and you only want to use integers for some strange reason, you can get your fraction, your remainders, by using the modulo operator. And where would you use this? Well, you can use it to maybe make your own clock. You can do a Google search on when you'll use the modulo operator, and there's a couple good use cases for it. So if I want to grab the time, this is a built-in value in pinescript. It just gives me the time in milliseconds since January 1st, 1970, UTC. So I divide that by 1,000 to get rid of the milliseconds and put it in seconds, and then divide that by 3,600 so I get it in hours. Now I have hours since January 1st. And then if I want to turn that into military time, I just divide it by 24. Well, I get the remainder if I divide it by 24. And the remainder will actually give me military time right now. So let me plot this. Military hour time. M time. And it'll be 0 through 24 for every hour. I'm on the 4 hours, so it's actually only going to show in 4 hour intervals. But if I go to the 1 hour, I get myself a nice little clock all the way up to 24. Well, 23, because on 24 it goes back to 0. M time. So right now it is 8 p.m. UTC. See the clock right here even says 2000, and we have 20. So that's how you do that. You can also do 12-hour clock by using the modulo for 12. So say if it was 15 was the hour, divided by 12, we get 3 p.m. Let me plot that so this makes a little more sense. So now this is a 12-hour clock. So it's like a little filter. You can think of the modulus operator as like a filter. So it only allows these intervals of 12 to come through, or up to 12. And if I want to grab the minutes in an hour, I can do the same thing here, get the time, divided by 60, divided by 1,000 to get rid of the milliseconds. So now I have 60 minutes, and then do the modulus for an hour, and I have minutes. I'm going to plot minutes. And I gotta get rid of these other plots or give them a color because it's kind of hard to tell what's what. 12-hour clock, undefined. This should be the only plot remaining now. Okay, 0. And this is because I'm on the 1 hour time frame, so the minutes always start and end at 0 on the 1 hour. So I need to go down to something lower than the 1 hour time frame. And this is the 15 minutes, so it's going to be in intervals of 15. 15, 30, 45. 5 minute and 1 minute. All the way up. So that's just a simple, just a way you would use the modulus operator. There's other use cases, but just to show you, it's there and you can use it. All right, in this section, we're going to go over variable operators, specifically comparison operators. And there are 6 comparison operators in pinescript. There is the less than operator, there's less than or equal to, there's a not equal to, equal, greater than, and finally the greater than or equal to operator. Now these do basically what you think they would do. And the result when comparing any two operands or more is always going to be a constant Boolean. And if you have a series, you're going to get a series Boolean. So you can compare numbers, you can compare strings, limited to just the equals. You can compare series, you can compare Booleans and colors and even labels and lines. So for numbers, it's pretty straightforward, very simple. You just use the operator between the two operands. So 2 is less than 2. It's going to be false, and it's going to return a constant bool here. And 2 is less than NA. You can actually use the NA variable within that. It's always going to be false whenever you're comparing against an NA variable. 2 is less than or equal to 2, true. This one's going to be true for 2 to equal to 2. Even floats, 2 is equal to 2.0. This actually ends up being true. In some programming languages, you might get false with this because they're different types. But in pinescript, it's going to be true. 2 is obviously not equal to 3, so that's going to be true. 2 is greater than -1, so this is going to be true. 2 is greater than NA. Well, this is always going to be false because it's an NA variable. 2 is greater than or equal to 2. This is true because it's equal. For strings, we can't use the less than or less than equal to. We'll get an error. We also can't use the greater than or the greater than or equal to for strings. We'll also get errors. So you are limited to just the equal or not equal to. So is this character A equal to this character A? Yes, they're identical. So that will return a constant Boolean. It's not going to return a string, it's going to return a Boolean. And that's going to be true for that. You can also, this is kind of unique here, an empty string with no spaces or anything is going to be equal to the NA variable. And that's going to be a true. If you have a space though in your empty string, it's not going to be equal to NA. That'll be false. So here we have this completely empty string is not equal to this spaced string. It's going to be true. It's not equal to that. For series, like I said before, the result is going to be series bool. You're going to get a series of booleans, so it's going to be true and false, or true or false, or all true or all false, depending on the comparison. And you can compare series against just integers or floats, even NAs. So here we have close less than 2. This is going to be true or false depending on where you are in the series. Close is less than NA. This will most likely always be false. Low is less than or equal to high. This will most likely always be true unless there's an NA variable somewhere in the series, because the low can't ever be greater than the high. It could be equal to it if the price didn't move anywhere in a day or whatever time frame you're on. Close is equal to 2. This is true. I mean, this could be true or it could be false. When you look at your series Boolean, you'll see the result of that. Close is not equal to the close. Well, this will probably always be false because they're the same thing. If it was close was equal to the close right here with these two, with this operator, then that would most likely always be true. And here the high is greater than a float. Well, that's going to be true or false, the result, depending on where you are in the series. And high is greater than low, greater than or equal to low. Similar to this, it's going to be true or false. Most likely it'll be true most of the time. And you can also compare against Booleans, except you can't use, similar to the strings, you can't use the less than or equal to, or the inverse of that with the greater than or equal to. So here we can just do, is true equal to true? Well, that's true. Is true equal to false? That's false. Is false equal to false? True. It's going to return a constant Boolean, and false is equal to NA. That's false. Is true equal to NA? That's false. So the only thing I've found that's actually equal to the NA is with a string, an empty string here. So that's actually true. So here, true is equal to 1. That's actually false. In some programming languages, you might actually be able to compare True is equal to 1 because 1 represents a high, 0 represents a low, and you can equate those to true and false. But in pinescript, you can't. So that's going to be false. Is false equal to a string? You get an error if you do that. So you can't compare booleans and strings. Is true not equal to false? Well, this is going to be true because it's not equal to false. It's equal to true. It's kind of like a negation. And moving on to comparison with colors, we can do color green is equal to color green. Well, this is going to be a constant boolean. That's going to be true. It's going to return that here, and it's going to say, yeah, that's true. Okay. You can even do the hexadecimal version of the color. So this 4CAF50 is actually the equivalent to color green in hexadecimal. And I'm actually testing if it's not equal to the same exact thing. So is this not equal to this? Well, that's going to be false because it is equal to that. And here I can actually compare the pinescript built-in variable for green to the hexadecimal version of green. And that's going to be returning true because it's equal to. Is this color equal to this? Yes, it is. It's the same color. However, if you are using hexadecimal, you need to make sure if you're going to compare two hexadecimals, I don't know where you do this, but down here I actually have the same exact colors. So these will output green because it's not case sensitive when pinescript is generating the colors from hex. But when you're comparing hexes, they need to be the same case. Otherwise, it's going to return false. So here, it's color green and hex, color green and hex, the same exact colors, but they're lowercase CAF. So that's going to be not equal. It's going to be false. Is it equal to that? Well, technically, yes, but to pinescript, no. And here I've just done a comparison of the results. So these are just booleans. And E color here, this is going to be true. Is it equal to E hex right here? This is false, so is true equal to false? No, that's false. So just to show you guys, here I'm going to add this to the plot, add it to the chart, and this is going to be E hex, which is this color. It's going to be false. So in order to show the booleans on the plot, we actually need to do this special ternary operator. You probably haven't seen this yet, but if it's false, it's going to return a 0. It's going to show a plot of 0. If it's true, it's going to plot a 1. And I can put any number here, but this is what I'm equating it to. Just true is 1, false is 0. This is how you plot booleans. So I'm just plotting this, and I'm plotting this. So this is actually going to be false, and I want to show you that. So they're actually both 0. They're going to be 0 all the way through. And you can compare labels and lines. This is how you initialize a line right here. Basically, you can put in some parameters here, and I'm just doing some basic initialization for some lines. So I got line 1, line 2, they're identical lines with the variables that you're initializing. So this is the line will start at x1, x2, x1, y1, x2, y2. So it's just the points that you can plot them for the line. And then the same one will start at the same exact point. But when I compare them, E line 1 is equal to E line 2. This will actually end up being false, because although they're identical lines, they are not identical objects for pinescript in the back end. That might be kind of confusing because they're the same in one shape, like visually they're the same, but the way they're identified in the back end, at least with lines and labels, you're only allowed to have maximum 50 in your chart. So they're unique. Each one is unique when you make a new line. and we'll get into that in another section. But just to show you guys, you can compare these, and you can do the same thing with labels, which is just another object similar to line. So to show you, I'm going to plot the results here of the line bool, and it's popping up as false, which is going to be 0 in this case. You can't plot false and true, so I've false is set to 0, and here we have 0 all the way through. So yeah, you think these would be equal, but they're not. And that's comparisons. In this section, we're going to go over some more variable operators, and specifically it's going to be the logical operations. And there's only 3 logical operators in pinescript. We have the not, which is a negation. We have the and, which is a logical conjunction, and the or, which is a disjunction. So what these do is basically the not just makes it the opposite. The and, if you have an and, both of the operands on each side of the and need to be true for the output to be true. And the or, it can be either one. So either or can be true. If they're both false, the output would be false. I'll show you in some examples down here. You can use these logical operations with numbers, with booleans, with NA, and with series. So here's some examples right here, and here is a not logical operation. So this not true basically going to be false, and it returns a constant bool here. And then the next one, not false, it's going to be true. It's going to be the opposite. If you put false not, that's not going to work. The negation needs to be in front of your operand. If I save this and I get an error, syntax error at input not. So it's not telling me exactly why it's not working, but you know why. So it needs to be in front of it. Can have something like down here. I actually have an example. So not false or not false. So you can use multiple negations in your statements. Before we get into that, let's keep moving down. Here we're going to do the and conjunction. So true and true, the output's going to be true because both of these operands are true. And for this one, it's going to be false because we have this boolean that's false. All it's doing is just imagine, like, you got 2 inputs and then 1 output. So for the and, this input needs to be true, this input needs to be true, the output will be true in the end. If either one's false, the output will be false. So here we see that this and bool 2 identifier will end up being constant bool is false. Here, false and false, it's going to be false, not even a chance. False and not false, now we're using the negation and the conjunction. So it's going to really be false and true. Still going to be false because we have the and conjunction here. And then this one, not false, so this will actually be true and not false. So it's going to end up being true and true. So this will be true. True or true. So with the or, as long as one is true, then the output will be true. So the same thing as the and, but it's either or. So here, true or true, it's going to be true. True or false, still going to be true because we have one true in here. False or false, it's going to end up being false. False or not false, it's going to be false or true because it's just negating the false, just reversing it. So it's going to be true, not false, which ends up being true, or not false, true or true, it's going to be true. So that's pretty straightforward with the booleans. You can do the same thing with numbers, and numbers are always true, even if they're negative numbers. So here you can do not 2 or any integer or float, any number you can think of. So this, since numbers are always true, it's just saying not true, which is false. So it's going to return a constant bool. And it returns a boolean, not another number. Just remember that. So when you're using these negations, these logical operations, it's always going to return some boolean, either a constant bool or some series bool. So here, 2 and 2, this is an integer and a float. It's just going to return true because both of these numbers are by default just true when you're comparing them with a conjunction, with an operator, logical operator. True or true, doesn't matter, still true. Negative numbers actually are true. So you would think that 0 might be false. In some programming languages it is, and a negative number might be false. No. In pinescript, negative numbers or 0 end up being true. So here we have true and true, so it's still true. The only thing is the NA is actually false. So here I put not NA, which is going to be not false, and it ends up being true. And I'm going to leave this script attached so you can see it and you can view it and you can look at these things and you can actually look at the output and see if this is correct. But I put the comments next to it so you don't have to do that. But if you want to verify, you'll be able to do that. And for series, same thing, not close. Sometimes in the series there are NA variables. So at some point in the series, maybe like the first one right in the beginning, close might not be available. So this could be true at some point, but this will mostly be false because the close is always going to be a true because it's a number. It's a series float, and it's always going to be true. So in the end, it's going to be a series bool. That's the difference. It's not going to return a constant boolean. It's going to return a series of true false. And I put true false here because there might be an NA in here at some point. In most cases, it won't be, but it's possible. So either or, true or false. Same thing here, close and open. It's mostly all the time it's going to be true and true and true. So the output will always be a series true. But in the minor case that one of these has an NA variable, or both, it could end up being false. Same thing here with the or, and you're getting the same thing, same return. You can even compare different, you can compare series and booleans. You can compare series and just straight integers or floats. This negation works between anything, really, not colors and other stuff. So what I have here, series and numbers and booleans. So close and true. The result is not going to be a constant bool. It's going to cast into a series because this has precedence over this. So series, true or false. And it might end up being false, like I said, if there's an NA here, but this will always be true. And this. So you can do all these different ways of comparing. And that's pretty much it with the logical operators as an overview. We're gonna use these in some examples in the future, but you guys need to be aware of these, and you can use these when you're making comparisons to have some kind of logic in your script. In this section, I'm going to show you guys how to plot to the chart. I wrote out this long script here. It's basically just a bunch of examples, and I'm going to go through all of it with you guys. But each section is separated by this horizontal line with the capital letters, and then I have the code inside of these star lines. So I made it nice and easy so you can work through it. I added little notes and little comments. Everything within the stars is something that you can, when you're working through it, you'll uncomment it and you'll see what it does. That's how this is laid out. So let's get started. The first section is the overlay. The point of this is to highlight the overlay argument. It's a Boolean, and all it does, when you save this script, it will add a separate window for your indicator to the main chart, or it will overlay on top of the candles or whatever you have for data showing up here. So as an example, I have this plot function here, and overlay is set to false. And with false, it'll show up in a separate window. And by default, the overlay is always set to false. So I could actually just have this. Basically, this is all you need. So let me save this. And nothing happened because I need to add it to the chart. And it's showing up there. And now if I change it to overlay true, which is the other option, it should plot to the main chart. The thing though is you'll notice that it's actually still plotting to this separate window, and that's because you need to delete that indicator and re-add it to the chart. That's the only time you need to do that, when you're saving in between code changes. It won't automatically change for you. So be aware of that when you're switching the overlay to true to false, just to see how it looks, and it doesn't change, just know that you need to delete it and re-add it. So now it's up here, and if you look closely, you'll see the blue line running through every close of these candles. And let me change these candles to bars so you can see it more clearly. So this is the plot function. And that's all the overlay argument does. It's definitely good to know when you're trying to figure out how to plot to the chart or to a separate window. And you can read more about it in the reference manual here. Next thing I want to show you guys is the actual plot function. You're going to be using this a lot. The basic plot function is this, just plot close, or any series you can put in here. It will just plot the close. Now you can get a little more complex. There's a bunch of arguments. There's 13 different parameters that you can change and edit. So here I put this on a separate line for each parameter so you can read it easily. I'm still plotting the close, but now I've added a title for it. I've added a color, changed the color to red. I made the line width, which is basically the width of this line, to 1. And the style this time is actually going to be a histogram. Tracking price basically is this red line here. It'll track the price of the plot. Trans P is transparency. 50 is right in the middle. It's 0 to 100. So 0 is opaque, which is you can see it fully, and 100 would be invisible. You wouldn't be able to see it at all. Hist base. This only applies to if you're using the style of plot style histogram, and that basically takes the histogram and it plots it at 6,000. Offset, that just moves the plot data off by -10 bars. You can do that positive, you can move the plot over here, +10. That's just how to move it back or forward on the x-axis. Join true, that only applies to if you're using different styles like stars or crosses or dots, and that just joins the dots together with a line. Editable, that's for style settings. You can go and change it if it's true. If not, then it won't show up in the styles. And display all, display is just if the plot shows up or not. It's display all or display none. Just to give you an example, this is now, we have the histogram being plotted for the close. And look, histogram base is at 6,000 and it's red. And it's offset by -10. So really it should start here, but it's offset -10 bars. And here's your style. So I can change this from plot style histogram within the actual settings to just a regular line chart. You can't change them all, like the offset doesn't show up in here, but the price line is the track price one. And you can change the color within here and the transparency. But notice that transparency in here is called opacity, and 100 is actually opaque, and 0 on here is invisible. You also change the thickness, but this opacity is actually the opposite. It's kind of strange. It's the opposite of the transparency here. So if I set this to 100, it would be invisible. But look, opacity in here is set to 0. So it's opposite. And then if I do editable, since that's the only plot I have, and I'm clicking this, editable is false, and nothing even shows up. But I can actually, if I save this other plot, then I should get a settings chart. So this is the only settings that pops up for this one. But because I put editable false, nothing shows up, at least when I only have one plot. And display all just basically turns it on and off. When you're changing the styles, just remember that in version 4, you actually put in the name of the output function that you're using. In this case, it's plot and period, and you can hold Alt and then you press space, and it'll give you all the different styles. So then you can come in here and select the one that you want. You can also do the same thing with display. There's only display none or display all. So that's the plot function. User inputs. So these are just variables that you can make and access within the settings. Right now there's only style because there's no user inputs. But once I uncomment some of these, they're going to pop up as inputs. So let me show you. Now, basically for inputs, if you want to put an input in, use the input function right here. And then you want to have a default value and you want to have a type. So for this first one of the input types I can put in is a Boolean. And if you look here, this is how the Boolean shows up on the inputs tab on the front end. It's just either true or false. And by default it's false, so it shows up as an empty box. And my title is this. If you don't put a title, it'll just put in your actual identifier name. And the type, just remember that the name of the function is input, and then period, space, and you can select all the different types that are available. So that was input bool, and this confirmation parameter. So when I add this to the chart, let me just remove this. When I add this to the chart, it's going to pop up and ask me to confirm the inputs. So I can go, okay, I want that and that. For integers, it's similar. You put in the default value. It has to be an integer. You don't have to put in a title, but you can. Same thing, input integer. Minval is just the minimum value. Confirm, step. Step is pretty straightforward. It's just this right here. So now it's going to step by 10 because I have that. If that's not in there, it's optional. It'll just go up by 1. Input float, very similar to the input integer. And notice my title is empty here. If we look, it actually used the identifier name and it capitalized the first character right here, input float. So, but it actually shows up as an integer in here, which is kind of strange. Well, 4.0 just rounds it to 4, but I can do that, 4.1. And this might be something where you'd want to put a step in so it steps by some, 100th or 1000th, really trying to be precise with something. Input string, you can put in any string you want. And what I've done here is I've used this options parameter. This is useful, at least in this case, where I'm giving them this list of options to be able to select in a drop down on the input menu. And you don't have to have that with the input string. And now see, these options all pop up. They don't do anything. It's just a string. That's it. And then I'll show you guys how to convert that later so it's actually useful. If you're using an options list, you need to have the default value set to one of the options. If it's not, it's going to throw an error in the error console down here. See right here, syntax error, line 73. Input def val should be in options, but 247 is not in either one of these options. So pinescript will let you know if you're doing something wrong. And I don't even need options. And then I can actually use 247 and you can put in whatever string you want. So now it's popping up, input string. I'm not gonna do that. It can be a number, whatever, because it's always converted to a string. And there's ways you can convert strings to numbers and vice versa. Input symbol, this one's useful and very interesting. Type input symbol. The default value is, I put BTC USD. You can put whatever you want. But basically what this one does is exactly the same thing as what this does up here. So if I want to type in a symbol and I want to have it part of my script, I can actually do that within my settings, my input settings. So then it just pops right up here and I can access every single symbol that's available to me in TradingView, which is very cool. You can work with that in a lot of different ways. Resolution, that's like the time frame here. You get this automatic drop down when you use input resolution of all the resolutions you can use. And if you're gonna put in a default value, 1 is 1 minute, 5 is 5 minutes. When you want to go to 1 day, you do 1D, and when you want to go to 1 month, you do 1M. So now this should by default go to 1 day. See? Input session will put it in a certain format for you so you can use it when you're actually doing sessions. And input source is for your series, your open, high, low, close. You can have access to high, low 2, HL3, and all the other ones. So this is just high plus low divided by 2, high plus low plus close divided by 3. You'll see this in a lot of standard indicators when you want to select the source for, say, an RSI. And these inputs work exactly the same way. So here, inputs, RSI, resolution, length, which is just an integer, and source. Now let's go on to plotting price levels. So this is for if you want to draw a horizontal line anywhere on the chart. Basically, you do this by typing in H line, which stands for horizontal line, and you put in some kind of constant value in here. It could be an integer, it could be a float. It's got to be a number, and it draws it at 6,000. There's also extra parameters like title, color, the line style. Notice how line style starts with H line, not plot. Mess around with these parameters, and now if I save this, I'll get 2 H lines that save to 6,000. You'll only be able to see one because they're going to be overlapping each other. And this works for overlay true or overlay false. So here's my 2 H lines overlapped, and you're seeing the gray one because it's a little bit thicker. It's got a 3 line width, and that'll pop in at the style as well. See how this one's got an actual title? So these are both the same thing. And by default, it turns up gray too. So there you go. And notice if you change it here, it won't save in the code. You need to actually hard code it and save it there. Otherwise, all your changes and effects that you make in the cog, this little cog wheel in the settings, they're just temporary. You can also assign these H-line functions to identifiers to be used later. So if you want to color the background between 2 H lines, kind of like they do in the RSI indicator, see how this is an H line here at 70, and this is an H line here at 30, and in between that is this purple fill. Now you can do the same exact thing with the fill function. And I'm doing it between this H line and this one at 5K. These right here. Let me save that. And because overlay is set to true, it's going to do it on the main chart. 10K and 5K. And the default color is blue. Again, you have access to those parameters like so. You can hover over the fill function and see all the other parameters that you have. And you don't even need to assign your H lines to identifiers to use it within the fill. You can just plot in that full function right there. But say your H lines were very verbose with different parameters, and they made this very long, you might want to separate it. Or if you wanted to use your H lines in another fill function somewhere, just know that you can't do that. You can't assign them, and you're only going to use the fill with H lines or plots. So you can assign plots as well to identifiers, and you can use them in fills. So now I have the plot high being plotted, and I have the low being plotted. I'm passing those into the fill function, and between those two values, it's going to be orange, and it's going to be almost fully transparent, like 80% opacity, and it's only going to show the last 50. So you'll see right here, this is 50 bars. The plot function still works. The plot's still plotting everything. It's plotting the high and low everywhere. These functions still work unless you put display none or transparency to 100. They're still going to show up. But then with the fill function being passed into here, you get the last 50. And another way of coloring the background is this other function called BG color. Similar to fill, except it colors the whole background. So BG color, as you can see here, it's just coloring everything in the background, the default color blue. And of course, like always, you have access to other parameters that are optional. The main thing is you want to put in a color for it to color. That's the only thing you need to input. But everything else is optional. And then this will just change it to red and it'll be offset by 1. So you can mess around with that. You can also color candles. So for candles, this one's interesting. It's called bar color, and the same thing as BG color. You want to input a color. That's the only input parameter that you need, and it will color the actual candle on the chart. And I put green. Here we go. Now all the candles are green, and these are bars. Let me change them, but they're all green. This one's kind of funky because I can change the overlay to false, so it makes a separate window, and it'll still change the bars in the main chart. So that's useful if you want a separate indicator in the window, but you still want to have some kind of indicator on the main chart. You can't do that with any other coloring function. So what I mean by that is, let me go up here, get rid of this, and now it's set to false. So now we get rid of this. I'm going to add this to the chart. It's going to be a separate window. So everything that I plot in here now will be in this separate window, except this bar color function, which will allow me to plot to the main chart. And of course, you get additional parameters that are optional: offset, editable, show last 100, and the title. Another thing about this that you should know is the order doesn't matter. So normally, the last line usually takes precedence over the line before it. For example, like all of these are green on line 126, and then the next execution in the script is to color all the bars blue. And you would expect now that at least the last 100 would be blue. Bar color, it doesn't actually do that. These are all green, they remain green. Plotting arrows. This is a useful function for your trade, like if you're trading and you want to plot like the size of your entry and you want to plot the direction, what you're going to do is you're going to put in an input. It's got to be some kind of number, and it will plot that. If it's a positive number that you put in here, it'll plot a green arrow, and if it's a negative number, it'll plot a red arrow, and they'll be reverse directions. So here I'm just taking the close minus the open. This should plot an arrow, and these arrows, the length of them is actually variable. You can see based on the difference of this candle size. Here, this is a very small difference. You could make it so it doesn't change at all if you mess with the minimum height and the maximum height area that are optional parameters. The default is 0 to 100 or 1 to 100. And you can change the color of the arrows. For color down arrow, it can be white. Color up, it can be green. And you can even offset them. So you might see that in the public scripts. If you ever look through the public scripts, maybe people will plot like some awesome strategy that they made, and it shows perfect arrows happening right before something goes up, and a perfect arrow going down right before the asset you're looking at goes down. Maybe you think this guy's got the holy grail of strategies, but maybe really they just took the offset and they did -2 or -3. There's also other ways you can plot shapes: crosses, triangles, flags, circles, arrows up, arrow down, labels. You just don't have access to the length of the arrow if you're doing an arrow up or arrow down. That's really the only difference. But you do have access to the size of the shape and the location. You can change the location. This one takes a different input. So here I'm putting in a series bool, and all this is the if the close is greater than the open. And this just returns in this identifier a series of booleans saying, okay, close is greater than open, true, or false. I can put that into the plot shape function. And by default, it plots a blue X. So whenever the close is greater than the open, it's true. Right here, green candles. And then whenever it's false, it won't plot anything. You could put in a series there. And if you put in the series into something that takes a boolean, it'll just make everything true. So instead, I would just get blue X's everywhere. Now, why would I want to do that? Well, there's a location parameter. This is basically the location of the shape that you're putting. But when you have absolute, you can put in a series, and it will take the value of this at the close, and it will plot it there. So all these blue X's will be plotted at the close instead of just above or below. And then the style, I did a flag here. So Alt, triangle up, triangle down. Let's do a diamond. And now this is going to be location absolute. I have the colors blue, offset input. And this is actually an input I used here. Let me uncomment that. And I put the default value is -1, input integer. And now this will show up in my inputs tab. And I can actually move the chart back and forth here. And the text, you can add text to it. It's not a flag. It's a diamond. Text color, you can change that. And the size is huge. You can change that to tiny. Do tiny. No, we'll do small. Save that. And now it's going to plot diamonds at the closes. Now we got a diamond at the close, but it's not over the close because I have the offset set to 1. And the offset won't show up inside the style parameters. That's why I put it as an input so I can mess with it here. This is much easier than saving. Now it's +2. Now this is over here. This is the close right now currently. 0 would be right over it, and it shifts it. So that way you can see how the offset works. And there's other shapes you can mess around and look at. They're all actually in the style right here. And actually you can change where it shows up. And since I put in a series float here, it's always going to plot. Below bar, above bar, bottom. Mess around with those, get a feel for it. The next thing I want to show you guys is plotting characters. Now this is like identical to plotting shapes, except you have a little more functionality with the shapes that you can plot. And you can plot any Unicode character you want. So I included this link to unicodetable.com. It's just a helpful resource for finding Unicodes. And Unicode is just really universal code for characters. This smiley face is a universal character, has its own Unicode. So how does this work? Well, same thing as the plot shape. It needs plot car, and I actually don't even need to put in anything else other than some kind of series. I'm using a series bool, same thing. And by default, it'll plot, I think, a star. Nothing really special. See, there's your star. Every time it's true, every time the close is greater than the open, it plots a star. But really, if you're going to use this, you want to actually put in a character. Here, I've just copy and pasted a character from here, from unicode.com, and you can pick whatever you want. I mean, these are all Unicode characters right here. And where you put that in is right here is car. Car is the parameter that you want to use, and you only can put in one character. If you put in 2, it'll take the first one. It won't give you an error. So I put this, I put 3333. It's only going to plot this finger down when the close is less than the open. So on these red bars, it's going to plot above the bar. But if I have a 3333, it'll plot the first character of this string, and it's green. And then if you want to get special with it, I made this little thing for you guys. It's taking this built-in function that just looks for the last bar. Available, okay, it is. Then plot a character at the close value times 10%. And then I use location absolute, so it'll plot it wherever I set the price here. So I want to plot it at the price, the current price times 10%, so it should be around here. And I made it size large, and I offset it +10, so it should be +10 bars into the future. And it's going to plot this little brain emoji. And I even put some text here. And then if I zoom out, there we go. Now that's this last close times 10%. Which is apparently right here in this general area, plus 10 bars. The next thing we're going to look at is plotting custom bars and candles. And this is basically if you want to plot your own candles like this, or your own bars like this. And you can do this over the main chart, or you can do it in a separate window. This is very useful if you're on a free account and you want to utilize the multi-layout. See multiple charts layout here. I can't do it because I'm on a free version right now. If I want to, I can actually have 3 additional charts with their own candlesticks on the main chart by putting them in separate windows. So it's one way to bypass the free version limitations. So this is the function that you'd use. It's called plot candle. The only required parameters are open, high, low, and close for the candlestick values. And I just put in the original open, high value, close that's available to me. So it'll plot the same exact candles you see in the chart now. You don't see anything because they're being overlaid by these candles. But if I hide the main chart, you'll get these. By default, they're going to be blue. They won't automatically change colors based on if they're a down candle or an up candle. So a little more complex example to show you kind of what you can do with this is I'm grabbing the weekly time frame here on the same ticker. So I'm using this security function, and basically what this does is it allows me to grab the weekly time frame. First parameter here is the actual ticker ID of the current chart I'm on, which is Bitstamp Bitcoin USD. So that's being one of the arguments in here. And then I'm using the 1 week, which is 1W, which is weekly time frame. And I'm passing it in this expression, this custom function I made, which just tells it that I want the open, high, low, and close from the weekly time frame from this same exact ticker. So now I'm getting these values returned as OHLC. These are my identifiers, and I'm passing those into the plot candle function. Don't worry if you don't understand this stuff. I will show you this later. But basically all I'm doing is I'm just grabbing the weekly values for the same ticker, and now I'm going to plot them. So this is good if I want to, plot the different time frames and only look at, like, say I want to look at the 1 hour, and I want to have the 4 hour, the daily, and the weekly and the monthly. I want to have my macro time frames just all in one chart. I can see that. So now I have the weekly candles being plotted alongside the main candles on the 1 day. And with the security function, it just plots it the same candle for all 7 days of that week. Now you can get rid of that with the security function. There's an option, so it only plots the first day of the week and then so on. So you won't see these duplicates. So if I go to the weekly now, you'll actually see these yellow candles will actually just be 1 week candles, and they'll line up perfectly. Can't even see them. There you go, like this. That's how you do that. The security function doesn't really work on a time frame that's higher than the one that you're pulling from, so I'll stay off the monthly. But as long as I'm lower than what I'm grabbing from, it works fine. And then now we're on to this, and I just set the overlay to false, so it's going to make a separate window. This line right here is basically putting an input in for the symbol, so now I'll be able to select the symbol, and by default I have XRP, assigning it to an identifier. I'm doing the same thing here with this custom function. Don't worry about that. I'm just grabbing the open, high, low, and close from the same exact time frame. And this is a built-in function that TradingView gives you, and it automatically changes to the time frame that your chart's on. So 4 hour, daily, weekly, this will always change to that. And then the ticker ID is going to be whatever I select as the input. By default, it'll be XRP. And this is doing the same thing. It's just grabbing the open, high, low, close for that ticker on the same exact time frame that the chart's on. And then this line right here is also probably going to be confusing for you if you haven't worked with pinescript too much. It's just helping me change the candle colors dynamically. So just like you'd see in the main chart, instead of yellow anymore, we're going to get, every time there's a positive candle, it'll change to green, and every time the close is not greater than the open, it'll change to red. That's all that's doing. And I'm using this identifier, which holds this series of colors, in the color parameter. So now the wick color, I can't make this dynamic. So it allows me to change the color of the wicks right here. But if I wanted to use this same color parameter, this color identifier that I made, this series colors, it won't work. It'll throw an error. And you can see that right here. If you go to the reference manual, for color, it's just simple color. And then for wick color, it's input. So the most you can put in there is a constant color or an input color. That takes a little experience to get used to, but I'll post a reference so you guys can see kind of how that works. But yeah, you'll get a warning, you'll get an error if it doesn't work. If you try to do something like that, you might be confused because you think, okay, I can change the color here, but why can't I change it here? Let me add this to the chart. Okay, XRP USD, and this is the only thing I have, and it pops up here. And let me see, Bitstamp, sure. And what do you know? I get this separate window with Ripple being plotted alongside Bitcoin. And I can do this up to 3 times. You know, I copy this, and here we go, copy, paste, paste. And obviously now I can go and I can change this to like gold or something. So there's one way to bypass this. Now you have separate charts. And plot bar, this does the same exact thing as plot candle, except it plots a bar. So just this. If you're into bars, use that. If you're into candles, use candle. All right, here's some more plotting examples for you guys to help you guys feel a little more comfortable. And this first one is I'm going to plot the volume weighted average price as a candlestick. So let me just uncomment this stuff and I'll walk you through it, what I'm doing here. Why would you want to do this? I don't know. You could build your own indicator, but I thought this was kind of cool. Now you can get your own candlesticks with some volume information built into the candlestick. The only downside to the volume, at least if you're using volume from TradingView, they don't have buy side or sell side volume. They only have the total volume of the candle, so you can't really see into that. So that's a whole nother subject. This could be useful though. What I'm doing here is I'm adding in the study function. I gave it a title of VWAP candlesticks, and this is going to be in a separate window because the overlay is false. And basically, I'm taking this function that's built into TradingView, which returns the volume weighted average price based on whatever series float that I input into it. For each one, I'm putting in the open, the high, low, and close. And I'm just identifying it here, V open, V high, V close. So these are all volume weighted open, volume weighted high, low, and close for the VWAP. Then, so you can kind of get the candlestick color differentiation, I'm using this ternary operator that you guys might be familiar with. I haven't showed you this yet. And all it's doing is returning a series of colors into this identifier. It's storing that. So if the VWAP close is greater than the VWAP open, similar to this, it'll change that candle color to green. And if not, then it'll be red. And then I'm using that in the color parameter for plot candle, so it changes the actual candles that I'm plotting, the color of them. And then I'm assigning the open to V open, the high to V high, and low. Pretty straightforward. I'm just basically using this function and I'm passing those values into the plot candle function. And I'm also going to plot the VWAP alongside it. It'll be somewhat similar to these candles, but they'll be obviously a little different because they have the volume aspect. Here we go. Let me add this to the chart. And here you go. Here's your VWAP candlesticks plotted right alongside these. And of course, if you want to switch this to true, you could do that. Save. Just remember that when you change that and you press save, it won't do anything here. It won't switch windows. I need to exit out of that, re-add it to the chart. Well, the volume information on Bitstamp is non-existent apparently because this VWAP isn't doing anything. Let me try a different time frame. There you go. Now you actually can see some different candles. Yeah. Maybe I could change the candlesticks to a different color so you can kind of tell the difference. Or you could just, this could be your new candlestick. You know, you could start trading with your volume built into your candles. Just an idea. You guys can use it. You can trade with it, whatever. I don't personally use this. I just thought it was kind of cool. The next one, just another simple idea you can do. Similar concept, I'm using the RSI instead of the VWAP. And same thing, there's an RSI function that you can use that's already pre-built for you, so you don't have to make your own RSI. You can use that, you put it in your source. Now the RSI takes two parameters. It takes a source of series floats, and it takes the length. So it's going back and it's taking all the opens for 14 bars, and it's going to compute the RSI for that. I'm doing that with the open, the high, low, and close. So I'm getting the RSI of all these series. And then I'm doing the same thing with the colors for the candles based on the RSI close and the open. And then I'm doing the same thing here. I'm putting it in the plot candle function. And I added these additional H lines here so we kind of get our own little RSI. And this will give us a custom RSI with candlesticks. Should be kind of funny looking. And I gotta actually delete this from the chart and add it to the chart so it makes a new window. And there you go, you got candlestick RSI. So that's kind of cool. Might actually be useful, who knows. Look there, the sell, buy. If you want, you can actually plot and add it in a plot here for the RSI and do like, this is the default RSI here, and see what that kind of looks like. If you're not worried about the limitations for amount of indicators on your chart, you can just add in the standard RSI and just cannot compile script. What happened? Mismatched input end of line. Oh, I'm missing a parentheses. End of line without continuing. Expecting, see this right here? Expecting this parentheses. And you can see a highlight that is closing. So let me add that in. Here, so this is what the original RSI would look like. Blue, it's not too much different than these candles. But if you didn't want to add in your own RSI, you can add this RSI on top of this. And here, there we go. Now I have the RSI and these candlesticks built into one indicator. But it'll show up as two indicators to TradingView. So if I add another one, if I try to add two more, then I can't because I'm limited to 3. But that's just a cool feature you can do. All right. Let's move on and actually build our own little custom RSI indicator. So here, I'm going to show you guys how to build a useful RSI. So these first 3 lines are just inputs for you to use because you're going to want to be able to change the parameters as you're messing with it. I have the length, which is normally what you use with the RSI. It's default 14. I put in the minimum value of 0 because you don't want to go negative. I don't think you even want 0 because you want a length of at least 1. 0 might throw an error. And max value doesn't really matter. So it's going to be an input integer. I gave it a title of RSI length. And then we want the upper and lower bounds, those horizontal lines between, by default, they're 70 and 30. So overbought and oversold, you can label them that. You can label whatever you want here, it doesn't matter. As long as the title is kind of indicative of what it's going to be. And then moving on to the calculations for the RSI, I am using an RSI that's actually based off of the VWAP. So instead of putting in the source, which is by default the close series, I'm going to put in the volume weighted average price. So I'm going to get the high low close divided by 3. It's going to be multiplied by the volume for each bar and then divided by the volume, and it's going to give me the average price. And then it's going to take the length, which by default is going to be 14, and then it's going to take the RSI of all that, and it's going to give me this VWAP RSI. So it's similar to the RSI except it's weighted with volume, and it's taking the average of the prices instead of the close. So for that, then I'm going to go, okay, I want these Boolean series here. Let me just plot this in the chart actually so you guys can see before I get into anything else. So far, this is what we have. we got 3 inputs and one calculation, one special calculation for the VWAP instead of a default RSI. Because here we go. Let me add this to the chart. And here we go. Now we have this RSI, but it's based on the VWAP. And if I compare this with the normal RSI, it's not too different. So you can use whatever one you want. This isn't any special error. It's not going to give you more or less indicators or entry and exits. It might. I mean, it might be a little bit better. I don't know. Statistically, you could look at it and go through, but that's not what we're here for. We're here to learn how to plot some stuff and learn pinescript. So it's kind of similar to the regular RSI with just the close. So the next thing I want to add some trading logic in here. And actually, before we do that, let me just add in these horizontal lines. So we have the upper bound, the horizontal line, and the lower bound. And these identifiers are coming from our inputs that we have here at 70 and 30. So now this should be almost identical to the original RSI, other than the fact that our line's a little different. And here you can change these like that, 74. 70 is the default, we'll keep it at that. So it's almost the same as this. We just need to color in the purple. And the way we do that is just this fill function, which I already wrote out. And upper HL, H line, and lower H line. And now it will be identical, except it'll be blue instead of purple. And if you want, you can change the color here in the fill. Color equals color. I believe purple is one. Yeah. And you got your own little custom RSI here. To take it a step further, going back to these calculations I made, very simple Boolean arguments. It's just if the RSI is greater than or equal to the upper bound. So if this blue line is greater than this value that we put, which is at 70, then it's going to be true. If it's not, it's going to be false. So this is true, 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 false, 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 true. No, sorry. This is still false because it's below this line. And then this second one is going to be if the RSI is less than or equal to the lower bound, which is this one, then it will be true. So this is true here. So we have two different Boolean series based on if it's above this or if it's below this. Anything in the middle is always going to be false between both of these. So right now it's not going to do anything extra, but we have these now, and now we can work with these. And down here, I'm going to plot some shapes. So if the RSI is above, which means if this is above this line, so when this is true, it's a series Boolean, when this is true, then I'm going to plot an arrow down shape. It's going to be above the bar, and it's going to be red, and it's going to say RSI is overbought, and the text will be red. So we should see that all right here. And it's way up there in the middle of 8,000, which is not good. So we actually want this to be top, because above the bar actually puts it at the value above the bar. This will actually put it in the frame of the window instead of in the frame of the price. And here we have it. And the text is overlapping, so we can get rid of that. But I'll show you the same thing. You do the same exact thing for the bottom. And now we got green. Oh, but it's way, should be like way up here. Yeah, see how it's misplaced? Because below bar, we want to use bottom. We could also use absolute, but we'd have to change this to maybe 0. But here we go. Now this is not really the prettiest thing. It's kind of ugly, so we're going to do it a different way. And right here, I'm actually just going to remove the text. And I'm going to plot the shape. But I'm going to do arrow down, location top, and it's the same exact thing. I just changed the location and I got rid of the text. So now we have, something a little more intuitive with these arrows. And if we want, we can use the plot character to actually plot our own characters instead of these arrows. I made these little inputs here, and I'm using Unicode characters or emojis, and I gave it options. So you can select your own down indicator symbol, and that's going to be put into the indicator character here. So I'll get rid of these arrows. Now you have the ability to change these to some bears or some bulls, and they'll also be in your inputs. Select bear symbol, select bullish symbol. And still not the greatest thing, but you can use it. The plot shape, if we wanted to get our arrows a little better placed, then we can use this ternary operator where we're saying, okay, if this boolean is true, then we want to price at the RSI, the actual value of the RSI. And if it's not, then just don't do anything. And in order to make this work, we need to set location to absolute. So now we're going to lose our little bear and bulls here. But now the arrows actually plot on the RSI line. And that might be like if you did overlay true, you can actually, well, no, it won't work like that. You have to change the scaling. So the reason why you want overlay false for this is because the scale is from 0 to 100. And since we're on 9,000 right now, the RSI would show up way down here. You could get these, you could not plot this at all. So if I change this to, let me see, I went back up here. I wrote this won't work with overlay false, but that was when I had above bar, right? Because it's going to plot it above the bar. And this one's going to plot below the bar. And now it changes overlay to true. And now it's going to plot it on the chart, on the main chart. And now you can get the RSI symbols. Let me add it. Right over the bars. Now, of course, if you come all the way down to 0, you're going to see your RSI being plotted down there. Which isn't good. That's where you'd use maybe the bar color instead, and instead of having an arrow here. Or you could just get rid of the RSI plot altogether and just use it in a separate plot if you want it. Whatever you want. There's many ways to do this. But now I have these. Okay, RSI oversold right here. So I don't even need the RSI indicator on a separate window taking up chart space. I can just have it right here, just plotting arrows. You can also use BG color to color the backgrounds. And here I've done kind of the same thing with the color. So all I want is, if RSI is above, color the background red. And if the RSI is below, color it green. So when it's overbought, color it red, because we want to sell. We don't want to be buying when it's overbought. And the opposite, green. And in the middle, it's not going to do anything. And this will color the background of this main chart. Like that. So here we go. I've got these arrows here. You can still see that. I could even do this. If I do this with overlay true, it's only going to do it in a separate window. Sorry, false. So you're kind of limited, when you're using this overlay parameter, except when you're using bar color. So now it's plotting it here, but I got to get rid of these absolute arrows. I can't do that anymore. They're not absolute, sorry, they're location above bar, below bar. If I change it to location top and bottom, it'll plot it in the correct areas here. So look, this is the same thing, but it's with bar color instead of BG color. And using the same expression. The only difference is instead of not coloring in what's in between, it's going to make it white, and it'll make the candles white. This way we can actually see because it's going to be red and green, so you won't be able to see the difference. So now, like, okay, so whenever the color of the candles are actually red, it just means the RSI is overbought. You see it lines up here. So now I could hide this. I don't even need to look at my RSI. Maybe if I wanted, I could change it to light. Whatever works for you. And I could just have my RSI plotting the bar colors, and you can add in tons of other stuff, obviously. But that's just some cool things, cool features you can do with the plotting function. For this lesson, I'm going to take everything we've learned, I'm going to build on top of that. And I think it's a good idea to show you guys how to build an indicator that contains multiple indicators. So I want to combine the MACD, the RSI, and the Bollinger Bands. So we're going to go over here, Pine Editor, and if you haven't already, open up a new script, blank indicator script. This is what yours should look like. And I'm just going to save it and call it multi-indicator. RSI plus BB for Bollinger Band plus MACD. Add it to the chart, and this is what we got. Just a basic generic default script, plotting the close. So let's get the RSI indicator in here. Now we can go over here, drop down, and find the RSI. The code pops up for it. We can copy and paste all of this. Come back to our code by clicking on our source code. Make sure we keep our study function in there, and then just drop that RSI code in. Everything should work fine. We should have the RSI now. Pretty simple, right? Copy and paste it. Now, let's see if we can do the same thing for the MACD. So come here again, MACD. And here's the code for the MACD. We can try copy and pasting this. Coming back to our script, and then maybe drop in the MACD right here. Try and save it, and see we're getting an error in line 21. SRC is already defined. Now that's going to happen if you try and copy and paste everything over. You're going to have conflicting identifiers. So what we could do is just rename this, press Command F on a Mac, and it pops up the find thing. So we'll find cert SRC. We can click this and do the whole word. And then if you click this little arrow here, there is a replace that we can use. And I want to replace SRC with MACD SRC. And I'm going to go through one by one because I don't want to replace every SRC, just the ones that are related to MACD. So here, it just replaced this one. Now it dropped down to this one. You can see it replacing SRC. And it just looped all the way back around. And we got to be careful we don't replace this one, because this is the source for the RSI. So that's it. So let's save that and see if we have any other issues. And voila, now we have the RSI and the MACD bundled together. Now it's not the prettiest thing, but you can scale this down and you can work with it in different ways. But this only uses one indicator. So if you're on the free version, you can still use 2 more indicators on your chart. Let's go ahead and add the Bollinger Bands. In the Bollinger Bands, there's a couple different selections here. We'll use this one. It's the default. Same thing. Come back to our code and scroll all the way to the bottom. Bollinger Bands. And we have source here, which we know caused a problem earlier. So we'll do the same thing. Control F, SRC, match the whole word. and we want to place it with BB SRC. And we'll go one by one. And it looks like it looped around. Do we have any other issues? Let's save and see. Nope. Works good. Alright. So, if you've ever worked with the Bollinger Bands, you know that they are bands that go around the price. So we have this smoothing average right here, a simple moving average, and then we have two standard deviations, plus the basis of the SMA and minus the basis. Basically, it's just going around the price. So here it's really throwing our indicator off because that's a price-based indicator, and these two are more relative indicators. So this doesn't really work too well. But that's one way to combine indicators. You just got to make sure you're combining the right ones. And if you want, you can scale these things down and plot them differently. But we're going to use it actually in a different way than just visually. Because we know how to use Pine, we actually want to just to automate our trading logic. So what I'm going to do is I'm actually going to reduce the majority of the code in here. So we just went through and we found the scripts for each one of these indicators and pasted it in here, and we made it work. It wasn't too difficult. But actually, we have 60 lines of code for 3 indicators, and they're kind of messy. So what I'm going to do is I'm going to reduce this to just 3 lines of code. So the RSI is actually a built-in indicator that we can call upon with pinescript. And to do that, we do RSI and then close it in parentheses. We put our source in here and then we give it the length. Now I know by heart that these are the default parameters for the RSI. Close is the source and 14 is the length. You can use these as inputs if you want, but right now I'm going to hard code them in. For the MACD, we can do the same thing. And we can remove all of this code. Actually, we'll keep the plot functions because those will be nice. So MACD, parentheses, and then it highlights blue. That's how you know you've got a built-in function. So the MACD is a little different than the RSI. It takes 4 arguments with the source, fast length, slow length, and signal length, and then it actually returns. You can see series float, comma, series float, comma, series float. It doesn't tell you what order it returns in, but it's returning a tuple. And you can click on it and look at this a little better, and they give you an example here. So this is how you would call it. So we can actually just copy this and paste it here. And notice the return statement is in these square brackets. That's because it's returning 3 values. So MACD with the default values here, close, 12, 26, and 9. And then it's returning the MACD line, the signal line, and the histogram line. And we can go ahead and remove this. So we have the histogram here. You can copy and paste this. MACD line. And signal line. And make sure these variables are no longer identified. So let's try that. Save that. And there we go. Now we kind of lost the color coding with the MACD, but we'll fix that. And let's do the last one for the Bollinger Bands. So Bollinger Bands, BB, parentheses, hover over it, get series length and multiplier for our arguments. And notice that it actually returns a tuple as well. So let's click on this, see if we can just get a copy and paste example. And this is the order the arguments come out as, middle, upper, and lower. So we get the middle band first, the upper band, and then the lower. If you get these backwards and you try to plot it, it's going to look a little weird. So boom. I'm assuming these are the default arguments right here, 5 and 4, close 5, 4. And then it's giving us the plot here. We can make this middle, yellow is fine, upper, make it red, and lower, green. And we'll drop in a plot here for the RSI. Give it a title, equals RSI, and give it a color, equals color dot purple. Now we got the purple RSI, the MACD, and our Bollinger Bands way up here. Now we can actually change this to overlay true. Save it, add it to the chart, delete the old one, and now we'll get the Bollinger Bands in the correct place. But our MACD and our RSI will be way down here. It's okay, it's just temporary. We know that they're there, we know they're working. So let's move all the plot functions down to one spot, just to organize our stuff. Plot, we can even do it further here, RSI plot, MACD plot, and BB plot. Okay. There we go. Now we have the same 3 indicators, a lot less code. Granted, we don't have the inputs now to change these as we want. You can add those in if you'd like. I'm going to keep it like this because we're going to be developing this a little bit further in the next sections after we learn a little more. So, there are 3 ways to program conditional statements in pinescript. We have what's called a ternary operator, we have an if function, and we have an if statement. Now I'm going to go through all 3 of these. I'm going to show you guys examples. Now you can use whatever one you want in pinescript, but it's really all a matter of preference. Neither one works differently than the other. They produce the same results, and you will see all 3 of them being used in pinescript when you're looking through other people's code. So you need to learn all of them, and then you can choose which one that you want to use. First one, which is probably the most common one that you'll find, because it comes from other programming languages like C# and JavaScript. So you learn this one, and you've already learned part of another programming language. So the ternary operator, basically what it does is it checks if a condition is true or false. Based on the result of that, it branches off and it executes a set of statements based on that. So if it's true, it executes a separate set of truthy statements. If it's false, it executes a separate set of falsy statements. And then I'll show you what that means. So the syntax looks like this. It's a little question mark and a semicolon. And you can type this in, and you can hover over it. It shows you in the reference manual. And basically we're putting in if, question mark, then semicolon, else. And here's another way I've written this out. So you have this Boolean condition. It's got to represent some kind of true false result. So the program can look at it and be like, is this true? And if it's true, if the expression here is true, then it executes this part of code. This part of the code gets returned into the identifier here. If this Boolean condition is false, it jumps to this part of the code. And then this part of the code is executed, and the result is returned into the identifier. So at any one time, either one of these, or one or the other, is going to be returned into this identifier based on if this is true or if this is false. So, first example, very simple. Here we want to know, is the close greater than the open? And if it is, we want to buy. And if it's not, we sell. And here I've equated the buy is equal to true and the sell is equal to false. So on line 27, I've written out this identifier called buy sell underscore ter for ternary equal to. Now here's the condition here. We're checking this. Close is greater than open. So this is always going to be true or false. Close is going to either be greater than the open or it's not going to be greater than the open. And the result of using one of these comparison symbols is going to be a Boolean. So it's going to be true or false. With this little question mark, if it's true, it's actually going to return another Boolean, which is kind of redundant. You wouldn't use it in this example here, but I wanted to make it as simple as I could. So simple it might actually be confusing. So if it's true, it's going to return true, and that's going to be put in here. If it's false, it's going to return false. Now that's probably too simple. So I made this second example here, where I've expanded on this simple example and kind of made each one of these components, each one of these expressions, their own little components. So this is the condition that we want to check for. This is the decision point we're at. Here we go. We need to make a decision here. Is the close greater than the open? Here we go. Okay. If the condition is true, we want to put in this string here called buy. And if the condition is false, we want to put in this string here which says sell. And here we have the ternary operator. So this condition here, same thing as the first example. Question mark. We're asking a question. And then if it's true, and then if it's not true, the only other thing it can be is false. So if it's false. So at any one time, buy or sell, series string variable identifier is going to contain the strings buy or sell. It's going to be a series because it's going to run and run and run. So it's just going to be a series of strings containing buy sell. Very simple. And then here on line 38, I'm actually taking that a step further. I'm using this result and I'm doing the same exact thing, except now my conditional statement here, I can wrap it in parentheses if I want. If you get a really long conditional statement, you can wrap it in parentheses. You can put it on a separate line. Doesn't matter. But here I'm wrapping in parentheses so you guys can see it clearly. So we have this result here, which is a series string containing buy or sell. And now, if it's ever equal to the same string called buy, then I want you to return the integer 100 into buy or sell position size. And if it's anything other than buy, now it can be sell, it can be A, it can be whatever. As long as it's not buy, it will always be false. So it will always return negative 100 whenever buy is not in there. It doesn't have to be sell, but in this case it will because there's really nothing else that can be in this variable. So we're always going to have in here buy or sell position size series of integers because now we're returning this. And then here we have the plot. I can save this, it'll add it to the plot, and we'll see either 100 or negative 100. Here. Whenever the close, our condition was whenever the close was greater than the open, which is basically just a green candle, we have 100. And whenever it's red, it's negative 100. So you see how this works. Pretty straightforward. You can get much more complex than this, but to keep things simple is the idea, especially when you're coding, because it's very easy to make things complex. Most of the time you don't need to. So example number 3, you can actually take the ternary operator and you can put more operators inside of it. and it'll act more, so you can get more than just two decisions inside of a conditional statement. You can have multiple decisions. So if this happens, then this happens, then if that happens, then this happens. If then else if then else if, just continuously until you find that your condition is met. So here I'm actually using an input function, and I actually want something that will change the color for me. I want to be able to select the color, and this is the way you would do it in pinescript, because there is no input type color that you can select. You have to actually manually use input string and then put in some options here. You don't need to use the options, but they're convenient. That way you don't have to type in green and make sure that it's lowercase, and this way you can just put your options there, put your colors, the ones you want to select. And then down here, I'm actually doing a multi-line, multi-layered ternary operation. And this isn't as complicated as it looks. So the first line is the color input from here. This is the condition. Well, it's part of the condition. I'm checking if this result, so it can be green, red, white, or blue. Let's say it's green because that's the default value. So, is green equal to green? That's the condition. Well, yes. Let me put it in parentheses too, so don't get confused. I don't know if that's simpler for you or not, but I'm going to assume it is. So, is green equal to green? If that's true, which we know it is, then we want to return this color green. And then color green will be passed into color selector. Everything else after this, it doesn't even go there. The code doesn't even look at that. It just hits this and goes, okay, that's the right, this is true. Okay, let's do this. Pop it in here, color green here, come down to this next line. We skip all this stuff, plot. I want to plot the close. Oh, it should be color. What color is the color selector? It's color green. And then we put editable false because we're selecting the color here. We don't want people changing the color in the style element. So here we save this, add it to the main chart, and here it's color green by default. The plot, we're plotting the close. Don't worry about this. This is just so there's no errors. But this one right here, inputs, pick a color, and then I put this little ternary operator symbol. And then we have green, red, white, and blue, the options that we put. And because I put non-editable, it doesn't show up in the style section, which is good in this very specific case. You can do that if you want, it doesn't really matter. But this is how I like it. So now let's say that the default value is actually blue, right? Which is way down here. Now what happens? Maybe you can predict what's going to happen. So, program comes down here. We check the color input. By default is blue. Color input is passed into this identifier. Then we come to line 47. And the program looks at this one. Color input. Is it equal to green? No. Okay, so it skips over this. And then it goes to this part of the conditional statement, which is the false part. So this is true, this is false. This is actually this line. I dropped it down. So really, you could have this all in one line like this, and this is where it might start looking confusing. This is where it's really hard to follow the logic when you put it all in one line. I've seen this many times before, and you're trying to you're looking at this and you're okay, this is the question, so this is the false one. And it's already getting confusing. So if you're going to write these out and put them on one line, please don't. Just figure out how to do multi-line statements, put them on multiple lines. It will be much easier to read. And easy to read code is what you want. So here we have it. This is the false statement. Now, this is a conditional statement inside of the false statement. So what the program has to do is it has to check this. It has to execute this piece of code. And this piece of code is saying, is the color put equal to red? Well, no, it's equal to blue. So we skip this because this would be true. Then we go to the false statement, which is the next line. Same thing. Is the color input equal to white? No, it's the next false statement. And then it skips the next line. Is the color input equal to blue? Oh, that's true. So, color blue. And we bring this all the way back up and it passes it into here. And then we can plot that and it would be color blue. So what would happen if none of these were selected? You can imagine that it would run all the way through. So we had some color in here that was like, purple or something. Now purple's not on on any one of our lines. So you'd expect it to go through, it would check each line. None of these would be true, so then it would go to the end statement. And when you're programming, you want to always have a condition that catches basically anything that you didn't plan. Just something that like, okay, I didn't expect this. This is the default condition. If none of the other conditions are met, it will always go to this one. So everything will be explicit in the code. There's nothing that just happens that I'm not aware of. And the default, if none of these work, it comes all the way down here and it executes the last line of the code, which would normally be the false statement, the else statement. So if, then do this, else. And the else, the last else, you could actually put this right here. This is technically the last else statement. The last false statement. This is the last statement that will be executed. You can call it the default statement. But it's the last one that would be executed if none of these are met. And basically you can put either a color, another color, like okay, none of these are met, I just want it to be color gold. No, that's not a color. Blue, orange, orange. And then it'll be orange. That one's executed if not. But in most cases, I just use the NA variable because that will catch everything. And then I'll know maybe I have a bug in my code if the color is not popping up correctly, because no color would pop up. If I put in color here, NA, then the close would be NA. Well, actually, let me show you that. Now, you can't put it in, like, say I wanted to put in an integer here. I know that doesn't make any sense, but you can't do that. You'll get an error. pinescript will throw little red flags at you, tell you can't do it. It has to be of the same type. It can be a different form. So if this is like a series of colors, then that would actually work. So here, color blue, let me see purple. And what happens? Now I have nothing on the chart because it's NA. So now in my code, I can go look at it and be like, oh, I didn't put a purple line in here. I need to go put in, I need to go do this and add in color purple. Then get rid of that. If purple is here, okay, that's what I forgot to do. And that's kind of like a good way to catch yourself when you're programming these long statements. Okay, hopefully that all makes sense. I'm going to move on to the next conditional statement, which does exactly the same thing as what you've just seen with the ternary operator. The if function, IFF. So, like I said, the IFF function does exactly the same thing as a ternary conditional operator, but it does it in a functional style. And this function is actually slightly less efficient than the ternary operator. So, if you're going for efficiency, then use the ternary operator. In most cases, it won't really matter. I've worked on some really long scripts and I have run into efficiency issues, but not so often where I have to really be sure of that I'm making sure that I'm using this operator. And if that's the case, you can always go through and just change it really quick because these are all interchangeable. So anyways, syntax is like this. We have an assignable identifier. We need to assign this function to something. And then the first one, the first argument of this function is the Boolean condition that we're testing for. The second argument is if this condition is true. And the third argument is if it's false. I can actually put in condition equals Boolean condition, then equals expression if true, else equals. I don't have to do that, but I could if I want to. And if it makes it simpler for you guys, then you can do that. Syntax error. Did I put that in right? Oh, okay. So see here, they put a underscore in front of it because this identifier right here, just the else, it's already built into pinescript, and we'll get to that actually in the next example. Undeclared identifier for Boolean condition. So apparently I shouldn't be doing examples with my syntax example. So here's a simple example. If the close is greater than the open, then buy, else sell. What do you know? It's identical to the example we saw in the ternary operator. And that's on purpose because I want you guys to be able to see the differences and not have to worry about the tiny details. So here we go. Buy, sell, if is the identifier for this. And the if function works like this. We have the condition in the first place, which is the close is greater than the open. If it is, then we return true. If it's not, then we return false. Very simple example. The only difference is we're separating these arguments by commas, which we're used to. You know, if we work with any other function that's built into pinescript, we separate our arguments by commas. So condition, if this condition is true, if the expression is true, then we return true. Redundant, yes. If it's false, then we return false. So if it's true, we return true. If it's not true, we return false. It doesn't have to be false. It just has to be not true. So logically, it would be false. Or NA. Actually, it could be either or. So, example number 2. This is going to be doing the same thing as we saw in the ternary example. It just takes this simple example and breaks it down in little parts. So we have the if condition. The conditional statement is the close greater than the open. Then, if it is, we want to return 100. It's true. And then if it's not, we want to return negative 100. So if condition true, if close is greater than the open, then branch and return 100, else branch and return negative 100. And here we have it set up just like that. So here's the function IFF, 2f's. If condition true, return then branch. If it's false, else branch. Then we're plotting this here. I'm plotting the result, which should be plotting 100 or negative 100, and it's going to be yellow. We save this, and then on 81, I'm actually plotting the same exact thing. I'm just using the actual words, the expressions instead of the identifiers here. So if close greater than open, return color green. So I can return a color. And then if it's not, just return NA, because you know what? Only thing I want is if the close is greater than open, I want the color green. Anything else, I don't care. Just NA. Give me NA. And I can plot BG color. So BG color will only make the background green whenever close is greater than the open. And alongside that plot, we're going to be seeing 100 and negative 100. And I have this other plot that I forgot to get rid of. And this is why I put them in between stars. So we can go back and remove the stuff that we don't want. So here, wait for it. All right. So here we go. We have 100 if the condition is true. Let me bring this down for you. Negative 100 if it's not true. This is exactly what we coded. So here's a condition, result, which we're plotting, which is an integer, a series integer. It's just flipping between 100 and negative 100 based on if the close is greater than the open. And then the second one is just flipping between BG color is green, BG color is NA. So it's nothing. And we see that right here. Green candle, close is greater than the open, 100, green. Anything else, NA, negative 100. And for example 3, we'll do the same thing as we did with the ternary operator. Multi-line statement with built-in extra conditionals. So here, same thing, we're choosing a color. We have the color with the option input string being returned into the color input identifier, and then we're just testing right here on each line. So if 2Fs, this condition, this input is equal to green string. Well, by default it is. So return this green. And notice I didn't close this parenthesis off like this. You might be tempted to do that. But actually, there's a comma there, and the false statement would drop down to the next line. Just like we did with the ternary operator. And just like we talked about with the ternary operator, I could put this all in one line. But you know how confusing that might look when you have nested if conditions, if functions. That's not pretty, guys. Now, tell me which looks better. This or this? Which one do you think you could understand more? Now, the answer should be obvious. It's this way. Multi-line. So here we go. Default, this condition is true. So color green will be returned. And we're going to plot. We're just going to plot the color as the close. Same exact thing as we did with the ternary operator. And now you're going to get a green plot line. There we go. We're plotting the close. What do you know? And we can do the same exact thing. You know, we'll put white here. And now the code is going to run through. It's going to see this. That's not going to be true. So it's going to go to the false part of this first argument here. And it's going to see that there's more functions inside of this. But it's going to just do it logically. And it's going to test the first function it sees. It's going to test the next line, which is this one. And then is this true? Well, the color input is white. It's a white string. And a white string is not equal to red. So that's also false. So it goes to the next line. And here, it's actually going to be true. So we return color white. And notice everything is closed off here with these parentheses. You got to get these right. And pinescript gives you a nice little green highlight so you can see that you've closed off your parentheses. So anyways, we're returning color white. It's going into here, and it's doing the same thing. It's plotting the color white. And what happens when we get a color that's not part of our statement? Well, I think you know what happens. We get the NA value, which is the last line that I put here. Now you can put NA anywhere, but it makes sense to put it at the end. So it goes through, test this line, false, test this line, false, test this line, false, test this condition, false, not blue, it's purple, not going to return this, it's going to return the false part. And the false part doesn't contain another if condition, it just contains NA. And it closes here, it stops. So NA is going to be returned because there's no purple. it doesn't exist. If we wanted to, we could put in another if condition here and put in color input if is equal to, and then purple. And now we can return color purple. We could return whatever we want. We could return color yellow. We could even return another if statement within this. Be kind of strange, but we could do it. And we always want to make sure we have some false condition in here. And now I need to add one more parenthesis. So you can see as you start to add on and tack these up and nest these, you're going to get a whole line of parentheses here. And that it'll be kind of messy. That's why I prefer personally the ternary operator when I'm nesting my if conditions. So that's two ways to make decisions. There's actually a third way. So the if statement is the third conditional operator available to you, and the last one. So, like the first one, its purpose and use case is identical. And the syntax goes like this. You have an identifier. Basically, you're going to assign the result of your branch to this identifier. And you go if, 1f, if, space, condition, and then you drop down to another line. You can't do this on the same line. The next line, and then that would be if this condition is true, then it returns that. And then you type in an else. This is a keyword. This is why we couldn't use else equals in the argument up here on example 1. This is why when we put else here, we got an error because this keyword's already taken by pinescript. It's reserved. We can't use this. And here, this is the false statement. If this expression, this condition evaluates to false, then it executes this line of code. So let's do a simple example here. Same exact thing as we saw in the first two conditional statements. And that's if the close is greater than the buy. If we get a green candle, then we return true. Else, we return false. So if close greater than buy, and here we have spaces. I'm using a tab here, 4 spaces. Returns true. Else, returning false. Now this looks a little more complex because it's on multiple lines, and I'll admit it is, but you will probably end up using this conditional statement more often than the others. So example 2, and you'll see why. So example 2, we can do the same thing, but we're going to do what we did in all these other examples. We're going to assign them to separate components, separate variables, separate identifiers, call it what you want. So close is greater than open. This is the condition. This is where this is going to be stored in. This is a series Boolean. And then we can even put the true branch on a separate line, which I'm doing right here. If the expression is true, I want to return the color yellow. And if it's false, I want to return the color white. So then, this is the if statement being executed. So we're testing the condition here. So if close is greater than open, and then it's going to be true or false. If it's true, then we execute this line. Color yellow. It's returned to BG color, which I've conveniently named BG color, the underscore, so it doesn't conflict with BG color. And then if it's false, then this expression will be false. And it looks like I'm putting in this into bar color. No worries, they both work the same, at least for argument's sake. Now, bar color is going to be yellow when close is greater than the open, and it'll be white when that's not true, when the close is less than the open, or maybe when the close is equal to the open. Any other condition where the close is not greater than the open, where it's not true, and where it's false, essentially, then it'll be white, and that'll execute. So moving on, to the next example, we can even do the long conditional statements like we saw in the other two examples. Now you're probably saying, what is this? And yeah, this is a little more complicated. It's not as clean, and you got to worry about your spaces here. So here we are. We have input, same input selector here. We're selecting a color, same exact thing we saw. Color is being put into this identifier, and then we're checking the condition. In the first line, we're going, okay, we have an identifier, so the result can be stored in here. We're going, okay, if this condition, this input string, is equal to this literal string that we've put in here, we can use parentheses here if we want. If that's true, then return color green. Well, the default value here is true. Is green. So this color green would be stored in here. The rest of these lines would be skipped, and the plot close would plot green. Let's change this. Let's make it what? Blue. Because we got to go all the way down. And I think you know how this goes, but repetition is the father of learning. So bear with me. Same thing here. Coming through, we're checking if this literal string blue from color input if identifier is equal to green string, green literal string. And well, actually, this was not a literal string. This would be an input string. This is converted. Anyways, still evaluated the same. Is it equal? No, blue is not equal to green. So we go to the next branch, and the next branch, as you would imagine, is the next line. The next line is this else statement, and what it does, it just basically says, well, if this isn't true, if this first line, then else, do this. If, then, else. If, then, okay, no, else. And then the else statement contains the second condition to check. And we use the if again. So else, if. It's like a switch. If color input, if, which is the same exact thing here, if the blue input blue string is equal to red, then we return color red. It's not. Blue is not equal to red. So else, if the color input is equal to white, return white. It's not. Else, if the color input blue is equal to blue, return color blue. It is, so we return color blue. All the way back up here, color selector if, and we plot blue. And you can imagine if we have something in here that does not work, what do you think is going to happen? Purple, not here. Not going to return this. Going to go to the next line. Else if equals red. Nope. Else if equals white. Nope. Else if equals blue. Nope. Else. We don't even need an if here. This is the default statement. If none of these work, else NA. And we return NA. NA is returned. We'll plot NA across the entire chart and nothing will show up because NA is not a color. What are you going to color? But if we want to add in this line, we can do if color input underscore if equals purple, and pinescript is pretty good. They bring your cursor to relatively where it needs to be. It's just 4 spaces. I use a tab, 4 spaces after the if condition, and then I put in the statement that I want to return, and that's purple. And I can get rid of this, but you know what? I still need a default statement at the end. So this lines up with the last statement. Can't have this over here. Needs to line up with the last statement. And then I do another tab and I put NA. I could put color white. I already have color white, but you get the point. I like to put NA because it makes sense to me. Now that's going to do the same exact thing as you saw with the other two conditional statements. So, pinescript recently came out with an update, and they removed this space mumbo jumbo here. So you don't have to worry about stacking your if conditions like this anymore. But I've showed you this because you will see it in other people's scripts, and if you don't see it now, you're going to see it then, and you're going to be kind of confused. So this is the way that we used to write this, used to nest if statements. The new way, and the better way, is now being done like this. And you can already tell this looks much cleaner. So you don't need to worry about spaces, and the only difference is you're doing the same thing. You have the if condition, you're checking that condition. If it's true, this still is separated by 4 spaces here. The return branch, whether it's true or false, is still going to be separated by 4 spaces. Or the true one, at least. Sorry. Only the true one's going to have 4 spaces. The false ones, so if this is false, it's just going to go to the next statement, the next else statement. And this else if statement is going to allow you to nest another condition here. And the other condition is whatever you want it to be, as long as the truth branch will be the same type as the rest. So here they're all colors, with the exception of the NA variable. So here, same thing. If this is true, which it is, then return green. Say if it's purple or blue, it's going to go through here. False, it's not green. It's going to go else if this green is equal to red. False, else if this is equal, if green is equal to white. False, else if this is equal to blue. What did I say, green? Okay, green was supposed to execute up here. Let's say I was on purple. Purple, no, purple is not equal to blue, else, NA. So this is almost identical to this, except it removes all the spaces and it just puts the if condition nested statement on the same line as the else. Much simpler, much easier to write out and read. Use that. But now you know that you will see this sometimes, and you'll know how to deal with it. You can just convert it if you want, or change it to some other conditional statement that you're familiar with and you like. In addition, with the if statement, you can actually do a couple special things. You don't need to assign the condition to an identifier. You can actually pre-assign your variable. So here I have this variable called is equal to color white, and say we could do that like way early on in the program, do a bunch of calculations, and then at the bottom maybe you want to change it and go, okay, you know what, if the close is greater than the open, then I want to change that variable. And we would do that with this walrus operator here. We can't reassign it like this. We reassign it with a walrus operator with a semicolon is equal to, and now we have this color change variable, this identifier changes into, it's no longer a constant color, it turns into a series of colors. So it's going to be color white, color orange, color white, color orange. It's going to flip back and forth depending on if the close is greater than the open. So this actually gets changed to this. Nothing gets returned here. We don't need to do that. Comment that. And then if the close is not greater than the open, we can go further and return NA. Well, there's actually a bug here. And it's a bug that you wouldn't see because this code right here would save perfectly fine. There'd be no errors. And just to prove that, I'm going to save it. See the red here, this is a new script. This is an unsaved script. Saving. And it's been saved. No errors. Clean. Works fine. We have orange.
and white, which is right here. I don't know what else I'm plotting. Plotting something else up here. Okay, let me get rid of this. Okay, so if you spotted this, then good. If not, I'm going to show you guys. It's okay. So, why is this a bug? What's going on here? Well, we have this if condition is closed is greater than open, and then it's assigning, if that's true, then it's reassigning this identifier to color orange. If it's false, it's going to drop down here and it's going to execute this line, which is NA. But where's this NA going? It's supposed to be returned to the identifier that this if statement is executing to, but there's nothing there. There should be an identifier here, but since we can use the if statement in this different way where we don't have to actually have something being assigned to, then this NA variable just gets lost. It just goes to dead null. It goes nowhere. And you might be writing something, you might have something different here, like color purple. I don't know what's up with purple today, but say you were expecting purple to change when the close is not greater than the open, but it's not going to happen because nothing gets returned. And you know what? We don't even need that else branch. That's another cool feature of the if statement here. We don't even need it. Automatically, it's going to return an NA. Again, it's not going to be assigned to anything, so it's just going to go nowhere. But if you want to make things simple, if closed greater than open, then change this color change identifier to color orange. If it's not, it's going to be this first line, because this first line gets executed. Comes down here, color change is equal to color white. And then we go to this line. If this condition is true, we're going to change that to orange. If it's not, it'll be color white for the rest of the thing. And that's why we see, orange and white. Now, if you didn't want white, and you still wanted as a default, if you didn't want white as a default, and you still wanted to use this statement here without assigning it to an identifier, say you wanted to do that, and you just wanted NA to plot. So you just wanted like some orange plot here. That's it. Whenever the close is greater than the open, you just wanted an orange plot. But you can't do this because you need to. pinescript is kind of tricky in the back end. It needs to know what kind of type this identifier is going to be. And the way you would do that is by actually just typing in the type beforehand. This is the only time you'll need to do this. Whenever you're assigning an identifier to NA. So here, you can use the type color before color change is equal to NA. Now the compiler in the back end understands that this identifier is supposed to be color. In most cases, if you just identify, if you assign it a color, it's going to be able to automatically figure out that this identifier is going to be a color. That's why you don't need to do this in most cases. But when it's NA, it doesn't know. It has no idea. It can't just skip ahead and look and be like, oh, you're actually assigning it orange here. I mean, I suppose they could do that in the back end, and maybe that's what they did with version 3, version 2, and version 1, because you didn't have to do the type before. But now they've made it pretty explicit, and you have to actually put this in here. And that's not the only way you could do it. You could also do this, and it should work the same. Built-in function cast. See right there, it says it cast NA to color. So here you have it. NA and orange. Now that we understand
all three of the conditional statements. Let's go ahead and look at all three of them kind of side by side so we can better understand them. I think this should help you guys really figure out the differences between them. So here, example 1. Now, the first line, I have a ternary operator, and I'm keeping it very simple. These conditions are simple. Is the close greater than the open? If we have a green candle, then return the integer 1. If it's not, return 0. And we're doing that with the same exact thing with the if function. If the close is greater than the open, return 1. If not, return 0. And the same thing with the if operator. If the close is greater than the open, then return 1, else return 0. So, let's check if these results are equal. How do we do that? Well, we want to be able to plot it so we can see the actual data and verify it with our eyes. And then here, I've created this separate identifier that's basically, I've named it ABC is same. It's a question. So is ABC the same? As in, are they equal? They're all the same? Are they 1 or 0? Are they all 1 or is 1 1? So the way you do that here is I have A equal to B, and I'm using this logical operator. It's A equal to C. And by principle, if A is equal to C, and if A is equal to B, then B is equal to C. So that's taking you back to algebra, I believe. So let's look at this. It's actually, I've built these in here too, so you can see separately A being plotted, you can see B being plotted, and you can see C. So we have all the variables being plotted, and we have this one which checks if they're all equal. And if they are equal, pinescript, you can't plot a Boolean series. You actually have to change that Boolean series into something else that's plottable. And I've equated 1 to true, 0 to false. So this is going to be true, false series Boolean, and I'm actually using a ternary operator in here. And this is something that you'll see a lot in pinescripts. This is, a lot of people will do this to convert their Booleans, maybe for debugging. You'll see this. And now we have, if it's true, we're going to plot a 1. If it's false, we're going to plot a 0. So we can't see the actual true-false Boolean here, but we can sort of see the result here. So here, let's open up the data window so you can see it better. So ABC is same. This means that A, B, and C are all equal to each other, and 1 is true. So here we see that C is 1, B is 1, A is 1. Well, those are all equal to each other, so A, B, C is same. That should be a 1, and it is. And here, well, it's always going to be 1 because A, B, and C are 0. So 0, 0, and 0. 0 is equal to 0, and 0 is equal to 0. That's true. So true is equated to 1 here. True isn't equal to 1. Don't get that confused. Some programming languages it is, but here I could put anything here. I could make true is not a string. You can't plot strings like that. True is 99, and false is negative 99. Oh, wrong thing. My bad. $99 and negative 99. Save as, save. So yeah, we see that this is all the same. So all of these conditional statements, all three of these, they do the exact same thing. So whatever one works for you, use it. And you see why I don't use 99 as a true variable, because now, look at this plot, it's ugly. What is going on here? I can barely see. Visually, I can't see anything. I see some ones here in this mini data window. So this is helpful. If I have something, if I have a plot like this that I really can't fix, or I don't want to, because everything's fixable, but you can just use the data window. You get it. 99 and negative 99. Okay, the negative symbol is showing up, but it's dark. Let me change the color thing to light. ABC is same. Oh wait, yeah, you're right. My bad, guys. It's never going to be negative 99 because A is always equal to B and A is always equal to C. At least in this case, because we're returning the same exact thing. If it's true, it's going to return that 1. If it's false, it's going to return 0 in all 3 of these statements. So we're actually never going to get negative 99. So a quick lesson on equality. Now, you noticed I wrote out this statement here a little differently than you would expect, or you might expect. I put A is equal to B and this logical comparison operator, A is equal to C. And then that gave us, by logic, mathematical properties here, we have B is equal to C. Now the reason why I didn't write it like this is because we won't get the same result. So we can actually see that here. I'm still plotting A, B, and C. I'm no longer plotting this. So you can see A, B, and C here respectively on the data window. We're still plotting exactly the same. And now I'm plotting these additional Boolean variables that are being equated to 1s and 0s. So if it's true, it's 1. If it's false, it's 0. Nothing's changed here. Now I'm just plotting this statement here. A is equal to B. If that's true or false, plot a 1 or a 0. Because here, it's just a statement. I broke it apart. A is equal to B. That should be true. And A is equal to C. That should always be true. Because we know these are always going to be identical. A, B, and C, we've established that. See, they're always 0, they're always 1. They're always going to be either 0 or 1. No matter what. That's why this was always true. But here, this isn't always true. We can see here in this plot, A, B, C is same. I'm plotting this now. And it's called A equals B equals C. You can see it here. And look, it's 0, 1. It's changing now. It shouldn't change. It should always be 1 because it should always be true. Because A, B, and C will always be the same. Whether that be all 0s or all 1s. I don't know how many times I need to say that. But you get the point, right? So this isn't evaluating correctly. But why not? Because A is equal to B. You can see that. It's always true. And A is equal to C. That's always true. That's always a 1. And then here we have, well, okay, if 1 is equal, if A and B are true, and B and C are true, or A and C are true, why aren't B and C true? And we can even plot B and C here as well to cover all the bases. And you're not going to see anything different. That will be true. So there's nothing here that's false. These will always be the same. ABC is the same, is already defined. Did I uncomment that somewhere? What's going on here? Okay. So let's look at the data now. Now that we have B and C in here, just to verify, one more verifier. Look at B is equal to C. It's all 1. What do you know? It's always true. So, if so facto, A is equal to B, B is equal to C, this should always be true. Because 1 is equal to 1 is equal to 1, or 0 is equal to 0 is equal to 0. But that doesn't happen, because this is 0 sometimes. So, what's happening here? Well, somewhere in the back end of pinescript, it's actually looking at this as 2 statements and not just 1, because there are 2 statements here. There's this comparison right here, There's two equal signs, and then there's this comparison. So there's two statements happening, and it's working from left to right. Maybe this is left to right for you guys. Anyways, it's working from left to right. That's the same no matter what angle you're looking at it. So here, it's going A is equal to B. It's executing that, and it's going true. We can confidently say this is true. And guess what? That result is returned here. And now it's testing, is true equal to C? It's not testing, is B equal to C? It's testing, is the result of this statement equal to C? So is true equal to 1 or 0? And guess what? It's not. So that's why we're getting here a 0 and sometimes a 1. And I don't really know why we're getting a 1 sometimes, to be honest, because this is always going to be true. And is true equal to 1 or is true equal to 0? Well, we can plot, sorry, we can do this, 1 equal to 0 and, sorry, 1 equal to true, and that will actually not work. S is equal to 1, watch. So now we can plot this, plot S, and we'll do the ternary operator here. 1 if it's true, 0 if it's false, and it's going to be false. And it's this plot right here. I didn't title it, but this one right here is at the bottom. It doesn't do anything. That's why ignore it. But look, it's 0. All across the board, it's 0. 1 is never equal to true. But somewhere in here, somewhere this true is, okay, I think maybe true is equal to 0. Maybe that's what you're thinking. Let's test that. So now we should see a 1 here pop up if that's actually true. It's still 0. So where is this 1 coming from? Guess what? I don't know. I don't know. It's somewhere in the back end of pinescript. Something is being compiled. Something is happening that I can't see. I can't see the back end. Maybe I can message someone, but it's not really worth my time because I can just do this and it works fine. Just don't do this. Try to remember when you're comparing stuff to that these are, at least remember that there's more than one statement here, and think that logically it's going from left to right. So A is equal to B. The result here is going to be whatever that result is, and then that result is going to be compared with the C. And the next statement. This could go on and on and on, right? It won't be A is equal to B and B is equal to C. Not like you think. So keep that in mind when you're programming. And then here, this last line here, this is the same thing we saw. It'll always be true, and it always is. This is what should be happening because we're using this operator here, and we're separating these statements. We know now this statement will be evaluated, and this statement will be evaluated. And with a logical operator, we can go and look at both of these. Results of both of these, true and true, will be true. So yeah, it's working left to right, but when the program in the back end looks at this, it just skips to the next statement and looks at this. It's still working left to right. Don't get me wrong here. It's evaluating this, then it sees this and then it evaluates this. It doesn't just go here and then just magically skip over here. It has to see this and. So it's still working left to right. But when it evaluates this and, it's doing something in the back end. Yeah, you don't see what it's doing, but there's some code that's running. Maybe it's in JavaScript. I'm not sure how their back end is coded in, at least to write this separate domain specific language. I imagine it's JavaScript. So that's what's happening. This is being executed. This line right here will be executed. Left So this is one statement, two statements, three statements right here, just between these. And then obviously you have this operator here, which is being evaluated. And this is inside of this whole plot function. So be aware of that. Hopefully I've drilled that into your head. Let me get rid of this stuff. And let's move on to example 1b. Kind of similar to what we just talked about. Except now, instead of returning a 0, I'm returning an NA value. And this is strictly forbidden. You look at the docs here, it says don't try to compare with it. Right there in the docs. Guess what? You're still going to do it. You're going to forget. Because I did. And I still do sometimes. But look. We're doing the same thing here. I've just labeled these A, NA, B. But the same exact thing as above. And now we're doing it the correct way. So we're evaluating this statement. And then the and now we're evaluating this statement. Both of them will be evaluated separately. And we know that A equals NA, or A should be either 1, but this time NA. But you think NA should be equal to NA? It's not. I mean, it is, but it's not. Not in the back end. Not in pinescript. You can't compare NA values. So ABC is same here in the data window. It's a 0 and a 1. It should always be a 1 because 1 is equal to 1 and NA is equal to NA. But when you're comparing NA to NA, something's going on there and it doesn't work. So that's another thing to be aware of. Same kind of deal with comparisons. We're a little off subject here, but you still need to be aware of these things, and this is the best way I can show you guys now because I can plot these things with the ternary operator. I can plot booleans. You can't plot booleans. You can't plot boolean series. You need to convert them. And now I can show you that. So this is what this is doing. ABC is NA because I can't compare NA variables. And you can see here that these are all, in this case, NA. They're all the same. Now they're 1. It's true, because 1s are fine. But NA, nothing happens. Something happens, but not the right thing. Let's move on to common mistakes. These are things that you'll do. I know because I've done them. This is what you're going to try and do. You're going to start learning these. You're going to start learning how to write if statements, whether that be an if function, an if statement block like this, or even a ternary operator. And you're going to want to put some kind of output function, most likely the plot. You're going to be like, okay, if this happens, I want to plot this. Sounds simple, right? You can't do that though. You can't do this. This will give you an error all day, every day. There's no way around it. Extraneous input 1, expecting end of line, and it gives you some. Okay, no, that's correct. That's why you click on this right here. But here you go, line 257. Click it. Cannot use plot in local scope. Okay, so we can't do that. Well, that's the same for all the other output functions. Bar color, plot candle, bar color, RPG color. They'll do the same thing. The only exception is the new functions in version 4, line and label. You can put those inside of conditional statements. Those are the only output functions that you can use. But those ones are exceptional and they're unique. But these ones, can't do it. Cannot use in local scope, cannot use in local scope. So what do? You can't even do this. This is a ternary operator. I could put the if function in here too. These are both the other conditional statements. You can't do that. I mean, this might be something you want to do. Like, okay, if the close is greater than the open, I only want to plot a close where the color is green. But if not, I want to plot the close where the color is red. It won't work. And here you get this long error thing. And it's actually giving you something different than this. The above cannot use plot, candle, and local scope. Now it gives you this. Cannot call operator with arguments. You get this big mess. I mean, this is, if you follow it, if you read it, it actually makes sense. But it takes a while to get through it before you find where you went wrong. And I can walk you through this real quick. So here it's just saying cannot call the ternary operator with arguments series bool, plot, and plot. That's what we have in here. We have this series bool right here, and then we have plot right here, and then comma plot right there. That's how it's looking at it. And then it tells you, okay, what you can do. Available overloads. You can have bool, bool, bool. So I can have all bools in here, like true, 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 or true, false, true, false. I can have bool, integer, integer. So this one could be a bool. And then I can have 1, 0. Sorry, 1, 0. Something over here. And so forth. All the way with floats, colors, series float, series integer, bool. But notice there's a pattern here. The conditional argument is always a bool, or it is a series bool, or an input bool. But either way, it's always going to be a bool, some kind of boolean. And then the expressions, the branch expressions here that are executed, whether it's that bool is true or false, they're all the same. I mean, they're going to be identical. So it's either two bools, two integers, two floats, two colors, series float. I mean, it can be any one of these except a plot or any output function. Here's all your options. You can look at it right here. Just type it in wrong. Series label, so you can put labels in there. Lines, series strings. So all of these are your options. But they have to be the same, and they can't be plots. So, same thing with the if function. And it gives you the same kind of error output. How do we fix that? What do we do? Well, we just make like we assign a variable, and then we assign it into the place for the argument. So if the close is greater than the open, I want to return the high, and I assign it to this variable here, and now I'm plotting the high. And guess what? If it's not, it's going to return NA. But with this if statement, I don't need to put this in here. It automatically does that for me. So NA will be returned, and that will do the same exact thing as we were trying to do up here. So if close is greater than the open, plot high. We know that if this worked, if it wasn't, then it wouldn't plot at all, because plot should only execute when this condition is true. Since we can't do that, we just assign it to a variable. We put it in this plot function here. So technically, this plot is taking up one of 40 of the plot outputs that we're limited to. We can have up to 40 plots in pinescript. And technically, it's always going to take up that spot, whether it's plotting nothing or it's plotting high. But at least this way, we can simulate it turning on and off. And if you look closely here, it goes from NA to the high. And we could fix that if we change the style. So align with breaks. And now it's actually plotting the way you'd expect it to. It's like kind of on and off there. That's how you do that. And for the ternary operator, if you wanted to change the colors, This might look familiar to you. I've done it before, but now I'm showing it. And here's your condition. And now I'm just assigning the colors to the true false. And then they go into this identifier. And then I just assign that to a separate plot, which will always plot. And it'll always plot these either or colors. And there we have it. It's gonna be green. Or red. Christmas colors for it. Green. Get rid of this. Close greater than the open. Color green. If not, red. Here it's green. Here it's green. There's 2 green candles, 2 green lines, and then red. Green. Pretty simple stuff. Now that we know how to use the ternary operators and how to correctly plot on and off conditional statements, conditional plots. How to plot conditional plots. Mistake number 2. Now this is something you might do as well. You can't assign different variable forms to your identifier between like inner branches here. So yeah, you can have this, here's your statement, we've seen this before. And then this branch, if it's true, we're returning a Boolean. That's true. It could be false. We can just do this so you guys don't get confused. And then if it's false, I'm not sure if that's more confusing now, but if this statement is executed because this condition is false, then color yellow would be returned. So we have a color being returned to this identifier or a Boolean. And guess what? That's going to throw an error because they're different types. pinescript doesn't know what to do with that in the back, so they just don't let you do it. Error, cannot compile script. So how do we fix that? Well, no workaround for that. You just either assign different ternary, you just make different lines, make different identifiers for the color. Maybe you do color yellow. If this is, you could just do something like this actually. You could do NA here and NA here. And then let me fix that. So that won't error anymore. NA works with any variable. Or you could just make sure that they are the same type. And that'll work too. One thing you can do is put in, this is a float. It's a literal float that I've dropped in here for the true branch. And then this is a series float. This works actually. This is fine. So the forms don't matter as much, but the type, if you're switching between types, it's not going to work. But if you're switching between forms of the same type, then it's fine. No errors. Everything's good. Plotting NA. It's all good. So, takeaway notes. You can use whichever method you choose of the 3. You can use all of them. We have the ternary operator, which consists of a question mark and a semicolon. We have the IFF function, 2 Fs. It's contained within parentheses, and the arguments are separated by commas, just like doing any other function that you might be familiar with. And we have the if statement, which is blocks. And you can use if else, if, or you can just do if. So you have 3 different choices. Try them out, see which one you like. Now you know about them. You won't see anything else in anyone else's script, and you'll know when you see them that they all do the same thing, and you'll know what's going on. So, which one should you use? Well, I would prefer just to use the ternary operator and the if function, the if statement. Mostly because I like to be efficient, and I think the ternary operator looks better. You can use whatever you want, but the ternary operator is more efficient than the if function. I haven't measured it against the if statement, and like I said, the if function is probably the least popular, but it's not a popularity contest. It's just what you like. You'll see it used a lot. I mean, it is useful. So don't let me throw shade at it and now you're not just gonna like it for some reason. So use it, use them all. And don't compare NA results. Saw that. And make sure you separate your statements when you're comparing anything. This is kind of separate from conditional statements, but it's something you'll be doing with conditional statements because you need to make that condition, and you're going to be comparing things in your conditions to create that condition. So don't compare NA results, and make sure that you use logical operators like and, or, between statements, and not just think that it's just one statement and everything is just going to work like it looks. Don't use plot, bar color, BG color in your conditional branches. You'll get an error. And return the same type of data. And that's it. Work with those and have fun. So now that we know how to use decisions and program ternary operators, if functions, and if statements, we can actually do a lot more with this script. So now I'm going to be including alerts for this script. I'm going to be cleaning up the plots, and we're going to be adding some more inputs, making it more usable. And I'm going to add some trading logic in for each indicator. So let's jump into it. All right, the first thing I want to do is I'm going to add some trading logic for the RSI. So one of the common trading patterns I see with the RSI is the RSI is greater than the 80. If it's overbought, then you sell. And if it's lower than the 20, then you buy if it's oversold. So we're going to program that in. It's pretty basic, but this will give you guys an idea of how to program your strategies. So we're going to go RSI strategy. And then we're going to program the buy condition equals. So we want to know for the buy condition, the RSI is going to have to be below the 20. So we can put RSI less than 20. But if we do that, it's going to trigger on every bar the RSI is less than 20. And I actually think we should do it so it's below and then it crosses back over. I think that would be better. So this is what I mean. We pull up the actual indicator here. I want the buy condition to occur not just when it goes below, but when it goes below and then it comes up. This little crossover right here. So we get a buy right here. We get a buy here. And then we wouldn't get a buy here, nor here, nor here. We'd get a buy right here. And we wouldn't get one here or here. We'd get one here. So it's below and then it comes above. It goes below and it goes above. That's a crossover. So not just when it's less than, we do it like this. We could do the previous RSI was less than, say, 30, and the current RSI is now greater than 30. That's one way to do it. Or there's this built-in function called crossover that does exactly that. And we just put an RSI here as the first argument, and then 30 here as the second argument. And you can read here, the X series is defined as having a crossed over Y series if the value of X is greater than the value of Y, and the value of X was less than the value of Y on the bar immediately preceding the current bar. And that's exactly what I just showed you. So this is the X value and this is the Y value. the RSI is crossing over the 30. That's the buy condition. We'll do the same thing for the sell condition, except opposite. And we'll do 80. It's 70 here, so we'll do 70. And we don't want to cross over, we want to cross under. So this is when the X series has crossed under the Y series, and it was once greater than it. The opposite of this. So if you look up here, just to be very explicit, you have this, it's above the 70, and then right here, it's now 62.58. You can see it over here. And now it's crossed under the 70. That's where we will get our sell condition. And we can plot this now. And instead of using a regular plot, I want to use a plot arrow. And we'll do buy condition. And since we can't just plot booleans, because this is going to be a boolean, this returns booleans. So you said series bool. We have to actually use a ternary operator here and put in either a 1 or an NA in this case. Because plot arrow is going to come in. If buy condition is true, it's going to plot an arrow. Since it's a positive one, it's going to be a green arrow. It's going to be up. And if it's not true, well, it doesn't automatically mean it's a sell condition. It could just be right in the middle. So we don't want it to do anything. And let's see what that looks like. We'll get rid of this RSI here. Here we go. And we have a buy condition here. So here we had a crossover. And it's only plotting the buys right now because I didn't put in plot arrow for the sells. And remember, if we do a -1 with the plot arrow function, it plots a red arrow in the opposite direction on top of the bar. Now we have the sells on there. So that's looking okay. Although here, this is where the RSI doesn't work very good in bullish trends. It's telling us to sell all the way up. But let's go ahead and do the same thing for the MACD and with the Bollinger Bands. And let's look at the MACD so we can kind of get an idea. I have something in mind. So a common pattern with the MACD for a strategy is to wait until this histogram here switches. So when it's green, it means we're looking for a buy, and we don't actually buy until this signal line goes over the MACD line. And the same thing here, when it's red, we're looking for the signal line to go below the MACD line. So we can plot that, and our buy condition, which we'll have to name MACD buy condition so it doesn't conflict. MACD buy condition is going to be equal to, and we want to grab, I believe it's the hist line, the one with the histogram, which will be the hist line. Hist line is greater than 0, so that's when it's green. And we want a crossover of the signal line and the MACD line. Let's actually confirm the colors of our signals over here. So down here, let's add in the color equals color red, and the signal line color blue. And fix this, comment that out so it doesn't cause an issue. Save this. Oh, we gotta add in a keyword. And if we come all the way down here, we can see our MACD. The purple line is the RSI. So this is the 0 line. The red line is our MACD line. And the blue line is the signal line. So come back here and we'll go cross over. So when the red line, the MACD line, crosses over the signal line. So when this condition happens, When it goes from here to here, and this is green, we're going to look for a buy. And we'll do the same thing for a sell. MACD sell condition. His line, we want less than 0. So now we'll be down here. And actually, let's fix this MACD. Let's fix the colors here on this his line. So one thing we can do with colors is we can actually dynamically change the colors. We can't do that with everything. So if you look in here, this is important for the forms and the types here. If you look in the plot function, we can see the arguments here. And this one's series, this one's constant string, this one's a simple color, input integer, input integer. Now basically what that means is we can only put input integers in this. We can't put some kind of series integer in here. We can use constant integers and input integers and even literal integers, but anything more than that, we can't do it. For the simple ones, we can actually add in dynamic colors, and they give us an expression right here, an example. But let's go. Let's add this in here. Do color. Now first we want to go his line greater than 0, and we'll use a ternary operator here. Then we want color dot green. If it's not greater than 0, well, we know automatically it's going to be less than 0, so we can do color dot red, and we'll save that, and we should see this be green, and below 0 will be red. Cool. Now we have our buy and sell conditions. Let's do the plot arrow functions. We'll just steal this code, drop it in here, copy this, paste, copy this, and paste. And with plot arrow, we can add titles, but we can't add text. So it might be kind of confusing trying to differentiate between the RSI buy and sells and the MACD buy and sells, but we'll fix that. So we save that, come back up here, and now we have a couple more arrows being drawn. But like I said, now we can't tell. We could change the colors of these arrows, but we'll actually end up using plot shape. Sorry, we'll use plot shape instead, because we can add text with plot shape. So we'll go here, plot shape. We're not changing the logic here, but we can now use text, and we'll put in RSI buy. We're down here, we'll do text equals RSI sell. We'll actually add a style to it too, because the default, I believe, is a flag or a snowflake. So we'll do this in style shape dot, hold alt, press space, and then we get all the options here. And for the buy condition, we want an arrow up. We want the location to be on the bottom. We want it to be below the bar. And we'll do the same thing here. Copy this for the sell condition, and we want it to be above the bar. And arrow down. And one last thing, gotta change this to plot shape. Now let's see how that looks. Okay, looking a little bit better. I'm gonna go ahead and get rid of this Bollinger Band here, because it's kind of annoying. At least comment that out for now. And I want larger icons, and I want to change the colors to coincide with the direction I'm trading in. So color equals color green, and I can do color text or text color. There we go. And I want that also to be green. And then we also have the size argument. We do size dot Alt space, and let's make it large. That's good. Let's copy this over and do the same thing. We'll make this red and make this red. Now, let's save that. Our Bollinger Bands should be gone, and we should have some nice arrows with text above them. There we go. So now we can see with the RSI is triggering the sells and the buys. Let's do the same thing for the MACD and then add in the Bollinger Band. So let's just copy this code, plot it here, copy, paste, copy, paste. Let's just get rid of these arrows. We're still plotting the 1 and -1 here. We don't need to do that anymore. We can put whatever we want. We can put the close here. It won't make a difference unless you actually change the location to location absolute. Then it would plot it at whatever value you have here. In this case, it'll be the close. So maybe a buy condition, if we change the location to absolute, it'd be better to have that arrow plotted exactly at the low. But these are minor details, so it doesn't really matter. And we have the same thing, MACD buy condition. It's always going to plot it below the bar whenever that condition is true. Screen, text color, we just got to change this to MACD, the text. And let's do the same thing for the Bollinger Bands. And to copy the text just like I did, I hold the Command key or the Windows key with Alt at the same time when it's highlighted, and I just hit the arrow, one of the arrow keys on my keyboard, up or down, and it just drops a whole copy of whatever I have highlighted. So we have the Bollinger Band strategy. We'll just change this. If I hold down the Windows key or the Command key and I click, it'll make multiple cursor points. So then I can actually edit both of these lines. And I'll do BB. And I actually don't need this because the Bollinger Band strategy is going to be a little bit different. Right? So let's figure out our Bollinger Band strategy before we plot this. Let's get the Bollinger Bands back up there again. Okay. So a common Bollinger Band strategy occurs when the price comes out of the band. And I think this multiplier is too big because the price isn't moving out of here at all. Maybe right here we get the high coming out. But if we change it to 2, it's just 2 standard deviations away. And that makes more sense. So here we actually see the price kind of getting on the edge. Here, here. And we can do something like this. We'll come over to our strategy, uncomment that out, and we'll do if the close for a buy condition is less than the lower. And for our sell condition, we'll do if the close is greater than the upper. Now let's see where that happens. Well, it doesn't happen much. Maybe here. Let's just see and plot it. Okay. I don't see any signals. So maybe we could use the high, which we have right here. We have here. Then we might be getting too many signals. You can mess around the parameters, but let's first get rid of, let's make a way so we can get rid of these RSI cells and the MACD cells, or make them optional, because right now they're kind of getting in my way when I'm looking for the BB. So what I want to do is add some inputs up here. For the inputs, I want to have some booleans, so use RSI equals input def val equals true, title equals use RSI, and then the type equals input bool. And what this will do is it'll create a checkbox, so it's kind of like a little switch, and then I can take this and I can put it over here, and I'll end it with this. So now the checkbox needs to be true for a buy condition or a sell condition to ever become true. So now none of those will plot unless I have it true. And I'll do the same thing with the other two strategies. Okay. Okay, let's go up here, and here we have our inputs now. Let's get rid of the use MACD and the RSI. Press OK. These will disappear. Okay, the RSI and the MACD are gone. Let's see if we can find the Bollinger Band. So we don't have any Bollinger Band signals popping up. So let's adjust this. And what we could do is we could create a Bollinger Band input for the source. So we'll do input BB and we'll do source. And we can kind of do the same thing here. And creating an input def val equals close, title BB input source, type will be input dot source, and this will give us a selection of the open, high, low, close, and the OH2 and OH3. Now we're going to make sure we substitute this here and here, and that should be it. And if we want, we could also change the length of this, add some inputs for this. So this isn't the input for the BB input source, this is the BB strategy source, because the input would be this one right here. So then we could go ahead and give an input up here for the actual input source. Make sure we change this to input BB source, give it some special name as iSource. Whatever makes sense to you. And we want the length here. Let's do like 10 instead of 5. And we'll leave the multiplier as 2. That's good enough. Save that. Okay, looks like we're getting a bunch of signals now. So let's get rid of these and try to reduce some of this noise. Okay, so now we can try and reduce some of the noise here so we get less signals. Or you could go ahead and combine this Bollinger Band signal generator with like the RSI or the MACD. And if you have both of them, then you issue a strategy buy or strategy sell. But we'll just go like this. You know, maybe the high is good. I actually made a little boo-boo here. I should have did the high and the low. So we'll keep that as the close and we'll keep it as 10, the default. There's a lot of signals there. It's not good, but we can work with it. So we're still plotting these plots, and we don't really want that. But we might want to have them optional just in case we want to pull them up later on and kind of see where our strategy is being issued. So we can make that optional by using an input. We'll do it up here. We'll do I and show plots, right? equals defval equals true. Title equals show plots. And type input bool. Grab this, copy that, and we'll bring it down here. Now here's all of our plots, right? To do this, we put this here, show plots, ternary operator, RSI, and then NA. So now it's going to come through here, and if this is true, then it will show the RSI. If it's false, it'll show NA. It won't show anything. That will essentially act as a switch to turn our plots on and off. Okay? And since we already have titles here, I don't really need these comments. I know what they are. But we'll do the same thing. This line, NA. In the BB plot, same thing. Give us a title. Remember, the order of the arguments does not matter as long as there's keywords. So BB upper, comma, don't forget that. Comma. Okay. Now we have that. Oh, mismatched input color expecting, and it looks like I missed a comma right there. Okay, so now you can come in here, select that, get rid of all of our plots. And they're gone. All right, now we don't have anything down here. No Bollinger Bands. Good. We can select, use RSI, use Bollinger Band, and we have inputs for the Bollinger Band. You can make inputs for the other two if you want, but you get the idea. MACD by. There's no MACD cells showing up. So what's up with that? This line less than 0. Crossover. This should be a cross under. There we go. And remember, just because you change it here, this is only temporary. In the code, you need to hard code it. So you got to change your defaults if you want them to always occur a certain way. So there we go. MACDs showing buy and sell signals. Looking good. Now let's add some alerts. So we can run this and we can have TradingView monitor it without our computer being open, and we'll get little alerts sent to us. So for alerts, we like to put these usually at the very bottom. And we're just going to combine all the sell conditions and combine all of the buy conditions and put it in one alert. So check it out. We have sell alert conditions. This will be my first variable. And I'm going to put all the sell conditions in. We have the BB sell condition. Copy that, paste that. And we'll use the logical OR operator with the MACD or the RSI. And we might as well rename this to RSI. Make sure we get it here too, so we're not confused. So we got BB cell condition or MACD cell condition or RSI cell condition. So if any of these conditions is true at any one time, then this will be true. And when that's true, we pass it into the alert condition. Built-in function pinescript makes available to us. And we do sell alert conditions. Title equals cell alert. Save that. This doesn't give you an alert right away. We actually need to set that up. So in order to set up the alert, we can either go here, we can go here, or we can go right over the indicator and hit more, add alert on my script. And here's the title of our alert we just made. Of course, there's other ones, but we want to select the one we just made. We have options only once per bar close, or once per bar minute. So we'll do just once. It'll only go off once. And then you can get expiration time here, open-ended. I won't touch that. Alert actions. You can get notified on the app, show a pop-up, email, webhook, get a sound, and email to SMS. And then here's the message. Create. And I'm on the 4-hour time frame, so that alert will only work on the 4-hour bars. Now we have to wait for our condition to appear, but this only works in the 4-hour. So if we wanted to see it, we'd have to go to the 1 minute and then set it up there and make sure the condition happened frequently to make sure our alert was working. The thing with alerts is once you set it, it goes into TradingView's back system and it doesn't change. So if I go into the Pine editor and I change the code here to mess with my condition, or if I even change the conditions here, this alert right here won't change. It's not reflected here. Like they're no longer linked together. So just be aware of that. If you come in here and you go and change your conditions and you think that the alert's only going to go off when the MACD strategy is set up, but it was set up with the RSI or the Bollinger Band or all three, you will be mistaken. So that's alerts. That's how you set them up. That's how you build yourself a little strategy with multiple indicators and mess around with that. Okay, this next lesson is going to be about functions. And what I'm going to do here is nothing unfamiliar to you guys. I'm going to walk you through, I'm going to give you a little intro overview. Then we're going to jump down into some syntax, how a function is worded, and then we're going to jump into some examples and the different features of functions. And I'll be plotting it onto the screen, going through examples and working through bugs and things to do, things not to do. Okay, what are functions? So a function is basically an identifier for a block of code. You're going to type this name in, and it's going to execute a block of code for you. And you might get a result from it, and you might not. So basically, we use functions when we're writing the same code over and over again, or it's a very complex piece of code. We'll write out a little function for it that will execute that block of code for us, and then we can use that function anywhere else in the code after the function's been declared. We only need to write the code once, and then we have this word that we create, this identifier that we can call anytime and use it. We can even pass custom arguments, so it's reusable and it can change. We can add in arguments into the function. So basically, functions make our code cleaner and simpler. So this is kind of what syntax looks like. You have this ID, which is the identifier. It's just the name of your function. It can be whatever you want. And then it goes in some parentheses. Now, you can have empty parentheses, or you can have arguments. And you can name your arguments whatever you want. The arg. They need to be separated with a comma. arg2, so forth. And they need to be distinct. But these are optional. And then from there you have this equal sign with this little greater than arrow. That's it. And you'll know you've done it right when it highlights blue. So this is a single line function, and you can actually write a function on one line. And the expression is after this. And this is what you're going to be, the block of code that you're going to be computing every time you call this function. Every time you run this function, this will be ran. And this can be an expression, or you can declare some variables inside of the function to be used locally. I'll explain what all that means. So a multi-line function is pretty much exactly the same, except it's on another line, and it's appended by 4 spaces. And you know me, I like to use a tab. So that's just the syntax. Let's actually get into some examples. And before we get into some custom function examples, I actually want to show you guys that you shouldn't be afraid of functions because we've been using them this entire time. So the study function that we use at the top of the script, this is actually a function. It's not a custom one. We didn't write this. This is one that TradingView already wrote for us. And this right here, this is an argument that we need to pass into this function. And if you hover over the study function, there is, see the syntax, it says in between the parentheses, you can read title, short title, overlay, format, precision. These are all the arguments, all the parameters that we have control over. Now, all of those are optional except the title. And we can do the same thing with our custom functions. So functions are nothing new. We're just going to learn how to write our own. Plot is also a function. SMA, that's a function. EMA, RSI, and I posted this link in here, which is just a link to the reference manual. And this is all the built-in functions. And you can go through them all. But these are all available to you guys. So before you go and try and write your own custom function, it might already be built in. And in most cases, you're better off using the built-in one because it'll probably be quicker. So go through those, see what pinescript has, and check it out. Moving on to a real example of a custom function, custom single line function. So here we are. I've named the name of my function name, and I gave it some parentheses. This is required. I didn't give it any arguments. It has no arguments, doesn't matter. And then the equal and the greater than symbol, and it's like a little house, little tipped over house. Think of it that way. And then on the thing that it's returning is going to be the close. So I can call this function actually within another function, the plot function, like this, as an argument. And when I run this, it's going to, the program is going to come down here. It's going to come to line 39. It's going to declare this function. It's going to see that, and then it's going to come to line 40, and it's actually going to call the function. And then it will actually run this. And when it runs it, it's going to come in here and then just see that this is the only line I have. It's going to return this variable, which is the close. And then it will plot it. It will put it into the plot argument, send it to the plot function, and then we all know what the plot does. It plots it to the screen. And we can see that here. And what do you know? This is just the close being plotted. And I could do overlay true, so it plots over here, but I don't need to bore you guys. Here's another example. Now we're using arguments. And I just want to sum both of the arguments that I put in here. They can be whatever I want. So I just gave it a name, sum these, parentheses, argument, comma, argument 2, and I can go argument 3, 4, 5, 6, 7, 8, 9, and so forth. And then a little tipped over house here, and then here's my result, my expression here. Argument 1 plus argument 2, which they have to be the names of your arguments. It can be whatever you want, but you can't change the name down here or over here. So this gets executed, or this function will be declared first. And then the code will come down, it will look at it, and then we called it here. inside of the plot function, sum these, and I gave it an integer 1 and an integer 2. So basically it's going to return 3. If I did everything right, we'll be plotting a series of integers. It'll always be 3. 3, 3, 3, 3, 3, 3, 3. What do you know? Here's some multi-line examples of declaring your own function. So, same thing. Function name, parentheses, no arguments inside. It'll tipped over house, and then we hit enter. It drops down to the next line, and then I hit tab. And then I put in whatever I want here. And here I'm just returning the close. I'm keeping it really simple right now. And then here I'm calling the function. In order to call the function, I can't just put in the name. I actually need to put in the parentheses. That means I'm calling it. That's how you call a function. Putting in the parentheses after the name, and that's going to call the function. It's going to do the same thing. It's just going to return the close. Nothing different from the single line, just different syntax. Okay, and it loaded. And what do you know? We have the plot of the close now. Same thing. All right, let's move on. Example number 2. Multi-line statement, multi-line function with 2 arguments. Same thing we saw with the single line example. We have sum this, I'm putting in parentheses, argument 1, separated by a comma, argument 2, tipped over a little house. And then on the next line, tabbing it in, or you can do 4 spaces, arg1 plus arg2. This is going to be returned. It's going to be executed, and then the result of this will be returned. But right now, this is just a function. It's being declared. It's not actually being run in the program. And then when we actually call the function, we do it here inside of the plot function. Now we actually don't have to do it inside of the plot. So let me simplify this for you guys a little more. We could just do this. Result equals, call the function like that. And here I'm actually showing you, I'm putting in a series float, which is the close, as the argument 1, and integer. So the type of the argument doesn't matter. As long as it's valid and legal inside what you're doing with it, like I can add a series in an integer. We've seen that. As long as that's valid, then the types you use here don't matter. And they can be different, as you'll see. Now I can plot the result of this, which we know will be the close plus 2, and will be a series float. Save that, load it up, and well, let's see, the close here is 9341, and we have 9343, so that's plus 2. Okay, moving on. A note on arguments, custom functions, and built-in functions. So built-in functions, as we've seen, the plot, SMA, RSI, and so forth, and custom functions, the ones that you're going to write and do your own custom code, are practically identical when it comes to semantics, the way you write them, the way that you call them. The only difference is actually in the arguments. And with built-in functions, you can use keywords, but you can't do that with custom functions. So the only way you can use the arguments with custom functions is by position. And basically, let me show you what that means. So the keywords for the SMA built-in function are, when you hover over the blue letters, you'll get the little reference pop up, and you'll see syntax SMA, parenthesis, source, comma, length. Now source is a keyword and length is a keyword. You can actually use those when you're calling the built-in function, as source equals close, length equals 14. Now we can't use the keywords that we make for our custom function. So if I wanted to use arg1 equals close and arg2 equals 2, that won't work, right? That's really the only difference. And basically a little further, my examples here go like, these are positional arguments. So they're basically in the position. We see that the first argument is a source, and we know that's going to be a series float. So I need to put the series float in the position that it would be in the syntax. And the 14 is going to be some kind of integer. So I put that in the length. Like if I put the 14 here, that's out of position. So as long as you can put them in positionally or with keywords when you're doing built-in. We can even mix them with built-in functions. But in order to mix them, you need to put the positional arguments first, and then after you're done with all your positional arguments, then you can use keywords. If you try to put a keyword before your positional argument, you'll get a compilation error and it won't work. pinescript will yell at you. So don't do this right here. Source equals close, and then here's your positional argument after. That will result in an error. So I actually made an example here of me trying to use a keyword argument. You try to run this, it will give you an error. I won't waste your time. Basically, this is a custom function. Here's my argument A, argument B, and then it's just a single line function. I'm just summing them together. And then I go and try to call the custom function with the keyword arguments. So A equals 1 and B equals 2. This will give an error. Can't do that. Moving on to scope. Now, any variable that you declare and define with an identifier inside of pinescript will actually have a thing called scope, and that's just the compiler on the back end looking at all the variables, and it knows everything that exists, everything that you've made, keeps track of all those. So anything you declare like outside right here is in the global scope. But inside of a function, it's actually going to be called the local scope, because that variable will only be accessible inside of that function. So I'm declaring this function, my custom function, passing an argument. It's a multi-line function, and I have multiple lines here. So this is the variable that I'm declaring inside of my function. And I'm just naming it local var. You can name it whatever you want, just like any other variable. And all it's doing is just whatever argument I pass is just adding 1. And then I'm just returning it. The next line, I'm just saying, okay, return this. I don't need that. In fact, it should just return this, but just for clarity, I'm going to do this. So the last line that you put in here will be returned. So now I'm calling the function. This is when the function actually gets run. My custom function, parentheses, and then my argument is 1. So now it's just going to come in here. It's going to look at this code. It's going to come back up here, run this, enter 1 into here. The 1's going to be passed to this. It's going to be 1 plus 1. And it's going to be assigned to local var. Local var will come down here, and then that'll be passed back. It'll come back here, and it will return into this result. And then I will plot the result, and we should think that the result will be 2. And I have it here, the title, result should be 2. Okay, and there we have it. But this variable right here, this local variable, like I said, the scope, it's only accessible inside of this function. I can't access it from another function that I make or anywhere else in the program. The only where I can manipulate and modify and access this variable is right here. If I want to work with it outside, I can't. I just pass the value of it back to this. So this is a different variable. It has nothing to do with this, right? It's just like me with 2 buckets, and I take this one, it's holding something, and I pour it into this one. These 2 buckets aren't connected. Okay, so if I wanted to do this, if I wanted to plot this local variable that I defined in here, I can't do that. I'll get an error. Undeclared identifier, right? So if I have a global variable that I defined outside of my function, like this, which I've conveniently named global var, I can actually use that inside of my custom function. And here I'm doing the same thing. I have a multi-line function, my custom function. Since I have this argument here, I need to pass it something. Now I'm sending a 1. It's coming in here, 1 plus my global variable, which is 2. And then I'm storing in this local variable. Now it's going to return 3. 1 plus 2 equals 3. The result 3 will be stored into this identifier called result, and then I plot it. Here we are. There's your 3. So that's how you work with global variables inside. The trick is, though, you can't modify your global variable inside of a custom function. It's kind of a downer. So here, I defined another global variable, naming it count. Now I want to kind of make a counter. So every time I call this counter function, it's gonna add 1 to this count variable every single time I call the function. So right here, I had the function that I've defined. There's no arguments. The only thing is, it's taking the global variable, count. It's going to count plus 1, reassign it to count, the walrus operator. So down here, I'm using an if statement. When the close is greater than the open, it's going to execute this function. It's got 0 to start. It's going to say 0 plus 1 is now the new count. And then it's going to loop back through, and it's going to count again and count again. And this doesn't work for actually a couple reasons. 1, because it's written incorrectly. And 2, because you can't modify the global variable, which is the point I want to get across. Cannot modify a global variable count in function. So it won't let me do this. And I'll show you what the other issue was in this next example. Let's actually build a counter and let's actually make it work. So let's do the same thing. Let's declare the count variable. This is going to be global as well. And before I uncomment that next line, I want to go in here and I want to show you this. I'm going to create this function. Same thing, counter. There's no arguments. And then I just took the if statement that I had here and I just put it inside of the counter. This is kind of what you want to do with functions. You want to put all the logic surrounding that function inside of the function to just kind of tidy things up. So it's going to check if close is greater than the open. Then I want to take the global variable count and I want to plus 1. It's going to return that, because if it's not, it's going to return this, the current count. It won't actually count. So what's going to happen is I'm going to run this function every single time. Every time the program goes around, on every bar, on every tick, depending on how you have it set up, the script's going to run. It's going to execute this counter function, and whatever the result is, it's going to store it inside of the count variable. So here it's being assigned 0, and then it's going to be 0 plus 1 on the first loop, or it'll stay 0, depending on if the close is greater than the open. And then that result will be stored in here, and then on the next turn, it's going to come through. It's going to take the previous result, and it's going to do that again. So it's going to count. It should. That's what you want it to do, right? Let me say that. And what's happening here? We're only getting 1s and 0s. Why is it not counting? That's because I intentionally left this line out so that would happen. Because you would probably code it up like this in the beginning. Because what happens in the script is it goes around. Every time it goes around, it redeclares all the variables. So on the first run, we come to count equals 0, sets it to 0, declares this function, right? And then it calls the function, and it takes 0 plus 1 or just returns 0, depending on this condition. Stores that result in count, plots it, and does everything else below the script. Then on the next bar, it comes around again, and what does it do? It comes back here, stores 0 back in count. We don't want that. That's why we're getting 0 and 1. Because sometimes the close isn't greater than the open and it's just returning 0. But it's never counting. So here, this line will fix that. Let me break it down so it's simple. I had to reassign the count variable right after I declare it. So I need to declare the count variable. Obviously, it needs to exist. And then on the next line, I'm taking that same exact variable that I just declared, count, and I'm grabbing the history. I'm grabbing the last variable that was inside of this, because this is a series, and I'm storing it inside of count. Now, this doesn't work just like this, because on the first run, there's only one variable being stored inside a count. The first time the program runs, it's going to be 0. Before 0, nothing exists. It's NA. So in order to comment that NA, because if it's NA here, we'll have NA plus 1, and that'll result in NA all the way through. So this is why we do this. We do NZ, and then we wrap it in the parentheses. And this is a built-in function pinescript gives to us. And we hover over it, we can actually see NZ, built-in function, replaces NaN values with zeros or given value in a series. So there's two ways you can write this. You can write it like this. So it's going to come in here, and if this count 1 returns a NA value, then it's going to give me a 0. If I wanted to, the default could be some other number. I could explicitly put return 0. I don't need to do that since it by default does that. But this is what I'll do. I'll be explicit. And here we go, NZ count 1. So now on the first run, it's going to see 0, and then count 1 will be NA because there's nothing before that on the first run. And then NZ will come in and it'll be like, oh, this is NA variable. Let me just return this, which is a 0, and then it's going to return 0. It'll come down here, it'll run this function, then it'll come up here, it'll go, oh, if the close is greater than the open, let's say it is. The close is greater than the open. So we're going to take 0 plus 1, it's going to be 1. Return 1. Boom, come down here, 1 isn't here, we plot 1. Then we come back around, another bar, another candle opens up, another tick. And then we come down here, we establish 0 to count again. But then we come here and we go, oh, you know what was the last value of count? And on the last value was actually 1 because we counted to 1. So it grabs the 1 now. And then the NZ checks. Oh, it's a 1. I don't need to do anything. It doesn't return 0. It just omits it. Nothing. So then we return 1 into this variable. We come down here. Counter runs if close is greater than the open. Well, let's say it is. It's going up. We're in a bull trend. And now we have 1 here. 1 plus 1. 2. Returns 2. We get the count. Now the count's 2. And all the way around, we keep doing that. And if the close wasn't greater than the open, it would just return the current count. And it would continue. It would just store the same variable back inside of the identifier. And that's how that works. And I'll save it so you guys can see. And this is how many times the close was greater than the open with the historical data that's available to me on this certain exchange. So let's move on to the next example. Returning more than one result. Now we actually don't have to return just one result, we can return multiple results, which is really useful. So here's an example. Now same thing, same way to identify and declare your function. You just have the name, the parentheses, optional argument, tipped over house. The only difference is you put it in between these guys. And then these are the two results that will be returned, 1 and 2. Now in order to call this function, you need to do the same thing to catch those results. So here's me calling the function on the next one. It's called fun. Calling it with the parentheses at the end of the identifier. And then I'm storing the results. First result, second result. Just in the same exact order. So they're in between the braces, right? Now I can go ahead and I can use these separately. I don't have to use them like that all the time. That's the only time I need to put them in between the braces to return them and to catch them. So now I can plot them separately. Plot first result, plot second result. There you go. Okay. Now you can do this multiple results on multiple line. Same kind of thing. You declare your function. Parentheses. Now I have arguments. arg1, arg2. And in here, I'm declaring some local variables. I have s equals arg1 plus arg2. S is just short for sum. Sum is actually a built-in variable, so I can't use that. M is the multiplication. So M equals arg1 times arg2. And diff is just the difference between s and m, so s minus m. Just some random calculations in here to show you that you can, have it longer than just one line. And then here's me returning 3 results this time. So here we go. I'm going to plot that, and it's going to plot 3, 2, 1. 3, 2, 1. There you go. Okay. Now let's get into something a little more complicated. I want to talk about function execution. So once a function is declared, it exists in the global scope of the script. Right? You can call it anywhere in the script. You can't call it before it's declared, but you can call it anywhere after it's declared. But that function doesn't actually run when it's declared. It only runs when you call it. If the function is never called, it will never run. Now right here, I'm defining 2 functions, 2 custom functions. This first one is just going to take in an argument, and it's going to return the previous value of that argument. The second one is going to just return the previous value of the close. And here, I'm going to plot this. First function, previous value, I'm going to pass it the close. I'm giving a color red, and I'm offsetting it 1. So you can actually see it line up with where it needs to go. So what it's doing basically, it's gonna plot the last value of the close. Pretty basic, right? Just like this one, it's doing the same exact thing as this one, except I'm passing it the argument. And there's that red line. Let me change this to bars so you can see the red line a little more. Right, and it's going through the close. Right, here's the close here, close there, and I offset it by 1. That's why it's not doing it here, and it's doing the previous value. So if I didn't put this offset here, this line would be forward 1 bar everywhere. But I'm just doing it visually so you can see that it lines up, right? Now, this is the other function that I made, which does the same exact thing. And what you would expect is for the same exact line to pop up, except this time it'll be white. Okay, so now we have 2 lines being plotted here. They're identical, so they're overlapping. You can kind of see a little red tinge underneath this white line, but it's there. They're both there. You can see here, you can see in the data window, right? Plot. They're both doing the same thing. Both of these functions look identical, and if you pass them the right argument, it's going to do the same thing. Now, this works all good until you put a function inside of some kind of conditional operation. So functions don't run every time the script runs. On every single bar, every single tick, the script's going to run here, it's 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 going to run here. And depending on your settings, it'll run on every tick or just on the close. But with functions, they don't do that. They only run when you call them. So we can see that in this example. So down here, I'm just taking the bar index, which is the entire count of all the bars in this chart. And it starts at 0, and it counts all the way up to whatever this is. It doesn't show me here. I could plot the bar index, and we could see. Let's just do that. Plot bar index, and we're going to get a large number. 5,592 is this bar. 5,593 is this bar, and all the way to this one, which is 5,601 bars available to me in this index. So what I'm doing here with this every other bar is just taking the bar index, I'm using the modulus operator with the 2, and I'm checking if that remainder is equal to 0. So every time it's an even number, basically, it will be equal to 0, and then this will be true. That's all that's doing. All I want to do is just get every other bar to be true. And then with that, I'm going to use a ternary operator. I'm going, every time this is true, I'm going to want to return this function right here. Previous value, close. Every other bar, I want to return the previous close. And then if not, just return nothing. And I'm going to make that blue. And the offset will be -1. You would think with this, here it would return the same exact thing as this one, except it would just do it every other bar, right? We'd get a plot here. It would be at this exact same point. And then this one, it wouldn't plot. It would just plot NA. And then this one, it would plot here. It would plot NA here. And then it would plot this close here. It would draw a straight line. That's what we would expect. Now, that doesn't happen. It doesn't happen because pinescript isn't running the function every single time. And with this close comes into here, there's a historical context being stored inside of the function. And it's actually taking the context of arg1. It's not taking the context of close1. It's taking the last value. The point I want to get across is be very careful when you are referencing global series variables inside of your functions. So if you have to do it, then you want to make sure that you're running your function on every bar. And the way to do that would be to just take out the function call from your conditional operator from your branch and just run it on every bar. And don't worry, because pinescript will tell you. If you pay attention to the console down here, it tells me right here the function 0 should be called on each calculation for consistency. It is recommended to extract the call from this ternary operator. So it knows. It's smart enough to know that I'm doing something messed up here. And now when you see this, you'll know why. So we know that these two were identical here when I plotted that. And now I'm plotting them again, but just on conditionals. Like, look how different that is. They should be the same because they're doing the same thing. But they're not because of this. So the way to combat that, we just go results 1 equals previous value, and then we put in the close here. And now that's going to be executed on every single bar. Then we get rid of this, and then in its place we just return the result. So the function is being called every single time, and then the result will be plotted. And we can actually keep this the same, though we shouldn't, because we shouldn't have functions inside of our ternary operators like this. But we know that it works. So now that it should match up. And there we go. Overlapping, doing what it should. Okay, so function highlights. Functions have to be declared before you use them. You can't use something that doesn't exist. With the exception of built-in functions. And I showed you guys here in the pinescript language reference manual. Functions can call other functions, built-in ones or your own custom ones, but they can't call themselves. There's no such thing as recursion. Functions can only be defined in the global scope. You can't define a function and then locally define a function inside of that. You can't build little function wrappers. It's not possible in pinescript. And once a function has been declared, it can be reused as many times as you want in the program. That's the beauty of a function. It's just big block of code, stick it in a function, then use that function, one little word, one letter if you want, and parentheses. Don't forget those. And the history of a local variable inside of a function iterates on every function call. And that's a reference to what I showed you up here in this example. So the history inside that is saved inside of the actual function, but it's a local history. And functions are only executed when they are called, and functions can return multiple results. Hopefully you guys understand how functions work and you can start using them in your programs. In this video, we're going to be talking about the var operator. So in the last section, we went over functions and we built a counter in one of the examples, and I actually grabbed that example straight from the script. So here we have the count is equal to 0, and if you remember, we had to put in this line right here on line number 7 to grab the previous value of the count so we wouldn't actually lose our count, because we know every time the script runs around it reinitializes the variable, so it would always be reset to 0. And we use the NZ here to catch any NA value. So in version 4, pinescript introduced a new variable that would do that for us, and we wouldn't have to put this special line here, and that's called the var variable. And all we do with that is we just use it before we initialize our variable. So I'm prepending count here, var count equal to 0, and that takes care of all this. We don't need to put in this line anymore. So all this does is it just keeps the state of this variable. It won't reset it. Whatever you initialize this identifier with will be the variable that stays in this until you change it further down the script. So this does the exact same thing as this. And you only can do this in version 4. Version 1, 2, and 3, this was the only way you could build a counter like that. And you'll see this a lot in previous scripts, so that's why I showed you guys. And if you look, I'm plotting here, plot count and Z, and I'm also plotting this one, and they're both plotting the same exact line. So now you know what the var does. It just keeps the state, and you don't need to worry about this unless you're going to go back and look at some older scripts from some people. But now you can work with both scripts. Okay, in this last part of the project, we're going to take the code that we just made and we're going to clean it up a lot. We're going to put everything in functions, and at the end we're going to turn it into a strategy so we can actually test each one of these strategies. So the first thing I want to do is I want to make a selector so I can choose each strategy. And to do that, I want to put them in a function. So what I'm going to do here is I'm going to do some major overhauling. And I'm going to get rid of all the plots and these use RSI inputs. So we don't need these plots anymore. We'll get rid of this. And the reason we don't need this anymore is because the selector will be taking care of turning these on and off. So we'll do strat. I like a little I for my inputs. Strat, short for strategy, select. And we'll turn that into an input. Def val. Our strategy will be called RSI. And we'll type input string, title, select strategy. And we want to give it some options. So we'll get a little drop down list here, and we'll add in the default value, which is the RSI, and we have two other strategies. We want the MACD strategy, and we want the Bollinger Band strategy. Okay, now that we have that set up, we're going to put the MACD, the RSI, and the Bollinger Band, along with their strategies, into a function. So I want to make this function up here, call it function, and strategy selector. It's going to take some kind of strategy variable, and that's how we're going to select it. We're going to pass it a variable, and then it's going to check that variable and then return the result based on whatever we pass it. So if strat, we're going to assume this is going to be a string we're passing it, is equal to RSI. So actually, it's going to be this. We're going to be passing it this input value into here. So imagine we pass the default value RSI. If strat, which would be that, passing it here is equal to RSI. Then let's just move this up and paste that in there. We also want to grab the RSI strategy. Okay. And for now, just gonna hide the rest of this stuff so you guys can see this working without any other complexity. So we defined the function, we declared it here. Now we actually have to call it. And to do that, I'm going to type in the function name, strategy selector. I spelled selector wrong. And then I want to pass it this input value, I strat select. Let me fix this. And if you look here, the last line that gets returned in this function will actually just be the cell condition. So I actually want the by and the cell condition to be returned. So on another line, I'm going to make this tuple RSI by condition, comma, RSI cell condition. Now both of these values will be returned. When I call this strategy, I also need to return it into another tuple that catches the by in the cell. So the first value returned is a by, second one is a cell. Right here. So what's going to happen? The script's going to start. It's going to see the input. By default, it's going to be RSI, which will be in here. It's going to come down here, declare this, and then it's going to see this. It's going to call here based on this value, which will be the input, RSI. So an RSI string will come up here, be passed into this. This if RSI will be equal to RSI, so this block of code will run. The RSI will be computed, and we'll have the buy and sell conditions computed, and then they'll be returned to buy and sell. And what we can do to see that this is working correctly is plot the buy and sell. And we'll just use the plot functions that we made earlier, but now we just got to replace this with buy and replace this with sell. So save that. Let's see what happens. And we're getting the same exact thing. Nothing's changed except our code is being laid out differently. All right. Now let's do the rest for the MACD and the Bollinger Band, and then we'll actually convert this into a real strategy. So the same thing here. We can put else if strat is equal to the other value we made for MACD, and then we can go ahead and just add this as well. Equals BB. So we'll grab the MACD, uncomment. Oh, that's the Bollinger Band too. Drag it up here, put it on a new line, fix our spacing. Remember, it's 4 spaces over, or you can use a tab. Now the MACD is getting computed here. We can go ahead and do the same with the Bollinger Band. Drop that in there. 4 spaces, 4 spaces. And we have the inputs here. We don't need those in here. Just get rid of that. And what was this before? The close. And we found that 10 was a good length for us. If you want, you can add these inputs up here again, but we'll keep it simple right now. So that's that. We don't even need these comments here. I think you get the point, right? So same thing, now we just have additional options for the MACD and the Bollinger Band. And we want a default option, else. And we'll just do NA. Now this function won't work because here it's returning 2 tuples, 2 values in the tuple, and here it's 3. We need to actually put in the buy and sell conditions for the MACD and the Bollinger Band before we can save it and it will compile correctly. Grab here, MACD, bring it up. Now we have that. We can get rid of these variables. We're not using these switches. And then return. We have to make sure that we're returning something on each one. And it has to be the same argument type and the same amount if we're returning a tuple. So MACD by condition, MACD cell condition. And up here we have RSI by condition or RSI cell condition. And finally for the Bollinger Bands, grab this, put it there. And we'll have to make it one more tuple for this. Make sure you're not getting these out of order. If you have your sell condition first, you want to make sure you're catching your sell condition here. But since I had the buy condition, it's always going to be buy here. So these are all buys coming first. Okay. And we were using this input for the Bollinger Band. We can just drop it up here. It has to be defined before we use it. So BB source, which is down here. Okay, good. So we shouldn't get any errors. And what I'll do is I'll get rid of this stuff, because we don't need this anymore. And you'll see why. So save. So return type of one of the if blocks is not compatible with return type of other blocks. And we see here it's giving us some kind of hint example. Series bool. This is what we put. And here it's showing us that we have an NA value, which we can use, but we need to put it as the same format. So for the else block, I need to do NA, NA. And that should fix the issue, because now everything that gets returned is going to be the same. So now I should be able to come in here and I can select the strategy. MACD. Notice how the text though is still saying RSI. Strategy is changing. But since we got rid of the other ones, other plots, or this text right here, and this text isn't dynamic, so we need to actually hard code it in or find another way to write out our strategies. So what I'll do here is I'll just change this to buy and sell. And at least now it won't be confusing. You just have to keep track of what strategy you've selected. Okay, so the next thing we want to do is we want to turn this into a strategy so we can run these strategies separately and look at the metrics in the strategy tester. So we'll need to change this function call up here to strategy. And that should be good enough. We can leave these here. And if we save, nothing's going to happen. We don't get any data in the strategy tester until we add in the strategy calls. So we need to actually add some strategy calls in this for this to work. So we can put if buy. And the way to do this is strategy dot. We get a number of selections. And the one we want is just entry. And we put the name of that order ID and call it whatever we want. Go long. And then we put in which direction the entry is going to be. Strategy dot long. And that's all you need for an entry variable. Obviously, you can get way more complex than that, but I'm not going to get into this. This is beyond the scope of this course. We'll do the same thing for the cell. Go short. Strategy short. And this is very simple. The script will run through. If a buy signal is present, this will become true. An entry will be set up. It only will open on the next candle, on the open of the next candle, and it'll enter an entry long. If that happens, then by default, only one entry will be open. Until it sees a sell signal, then on the next candle, that order will be closed. And then we can go back through and we can open up another buy. So for example here, we won't get a sell every time. We'll get a sell just here. And then these two will be missed because we only can have one. There's a way to go up here in the strategy function and add in pyramiding. but I won't show you guys how to do that. You can experiment with that. That is beyond the scope of this course right now. So let's save this. And now we can see our strategy popping up. And I left these plot shapes in here so you guys can see the difference between when your signal is generated and when the pinescript backtester actually opens your trade. So we are on the default RSI strategy. The RSI signal was generated here on this bar, but it wasn't until the open of the next bar that the entry order was submitted in the backtester. And then we went long. And since we don't have really an exit, a take profit or anything, by default, strategy entry won't close until it gets a short entry. And that happens when we sell. So here the same thing happens, and now it's going short. So it's just switching sides, switching positions every time. And then it only goes short once. There's no pyramiding. But that's a profit right there. That's not bad. But then here, we're still in the sell position. We have no stop loss. And you can look at the strategy tester tab here, and you can look at your profit. By default, too, the strategy tester starts off with, I believe, you can go to the properties here. This new tab opens up when you use the strategy. Initial capital, 100,000. So it looks like we lost the majority of our funds. You can use a base currency. You can actually mess with pyramiding in here. And you'll see a couple more orders appear. See, now I have 2 orders appearing here. Go short, go short, go short, go short. We did pyramiding 3, so 4, 5, and 6 won't happen. But go ahead and mess around with these. Get comfortable with it. You can add in commission, slippage. And now you can go in and you can test each strategy that you make. So if I come in, open the strategy tester, and I come over here and I switch the strategy to MACD, you'll see that the MACD strategy, the metrics change a bit, and it looks like this is a profitable strategy. Now, I wouldn't bet everything on this. There's still lots more to work to do, but as a first outlook, you can see this, and you can be like, okay, maybe this is going to work. And then you go back and you improve on it if you can, and you want to start forward testing it and see how it works in real time. Don't ever just take a strategy, look at the back test results, and think that you've got a winner. That's not how it works. But that looks promising. 17% profit. We're on the 4-hour time frame. Remember though, there's 0% commission set on here. Normally you're dealing with at least 1%. And there's also ticks, slippage, depending on how much money and volume you're moving. And automatically, just on the 1% commission, now we're losing money. So we just went from a good strategy to a bad strategy. Unless you can find a broker with 0% commission, I would not trade this. So be aware of that. And then obviously we can look at the BB strategy. Again, I'm losing one. Sorry guys, I can't give you the winners. But now you have this script, you have the know-how. You can add to it, add in inputs, add in different strategies. You can come in to the functions in the public domain and add in other people's strategies and start doing your own testing and back testing and building your own indicators and figuring out what works and find something. Start building strategies. Start building your own indicators. You can set up alerts and do whatever you like. So one final quick thing on strategies. I know I mentioned earlier in the course that you could not use the alert condition inside of strategies. That's still true. But recently, pinescript has made it available to you to add an alert to your strategy. And you don't even need to add in the alert condition for your strategy. So all you need to do is do exactly what you would with the study feature. Come here, here, or here, create the alert, put it on your script. So automatically, every time your strategy enters an order or exits an order, you'll get an alert. So again, you don't need to create the alert condition inside of your code. You don't need to change your code at all. pinescript just added this in, so strategy alerts are live. And I'll leave this blog entry in the resources section so you guys can check it out. Okay? Congratulations on making it to the end of the course. Here's to you. pinescript is a growing language that's getting better and better every day. By now, you should have a good understanding of how Pine works, and you should be confident in making your own indicators. But there's still much more to learn. So, in the resources tab, I've included some links that should take your coding skills further. Check those out to continue your learning journey. If you like this course, please leave me some feedback. And if you're interested in something more advanced, I'd love to hear your thoughts and suggestions. I have a few ideas on generating a course that covers topics such as connecting indicator and strategies with third-party services, correctly developing and backtesting strategies, optimizing scripts for speedy execution, how to earn money coding scripts for other people, advanced plotting and drawing techniques, and more in-depth code-alongs pushing the boundaries of pinescript. And if you didn't like the course, please still leave me a review so I can fix it, or just contact me directly. Don't leave me a bad review. Maybe I can fix it. That being said, thank you for taking this course with me. I wish you the greatest success in all of your endeavors. God bless and Godspeed.